So, good day, Sir Punsalan and our classmates. So, we are now in Group 13. So, our topic for our report is the ASMT or the American Society for Materials and Testing. So, my group mates are composed of me, Michael Agagumpad, Marvin Malparta, John Paulo Monfero, and James Montero. Next slide. So, ASMT or American Society for Materials and Testing. ASM, ASTM International, formerly known as American Society for Testing and Materials, is an international standard organization that develops and publishes voluntary consensus technical standards for a wide range of materials, products, systems, and services. So it is founded in 1902 as the American section of the International Association for Testing Materials. Next slide. So, so for the history of ASMT, a group of scientists and engineers led by Charles Dudley formed ASTM in 1898. So to address the frequent trail breaks affecting the fast-growing railroad industry. So the group developed a standard for the steel used to fabricate rails. Originally, the American Society for Testing Materials in 1902. So it became the American Society for Testing and Materials in 1961. ASTM officially changed its name to ASTM International and added a tagline standards worldwide in 2014. In 2014, it changed tagline to helping our world work better. So in June 9th, 2022, it was announced that the European Committee for Standardization, or CEN, and ASTM International have agreed to extend and expand a technical cooperation agreement from 2019 in order to broaden and facilitate global dialogue and coordination in specific standardization areas of mutual interest. So by extending and expanding this important agreement, ASTM International and CN reaffirmed their commitment to a series of practical actions to implement their cooperation, specifically in the technical areas of common interest between ASTM and CN. So this these common interests are explore opportunities to collaborate within their respective standards development processes, facilitate technical standardization, dialogue between their technical bodies, and share information on their standards development activities and emerging technologies, trends, or regulatory drivers of mutual interest for the benefit of the stakeholders. So next slide. Alright, so our report composed of 4 volumes. So we are focusing for the about the electrical standards in the ASTM. So for ASTM Volume 1, volumes uh, 10.01 and 10.02 include standards covering ceramic and mica products, composite and textile materials, flexible sheet, tape and tubing, plates, rods, and molded materials, electric heating unit installation and electrical test, hook up and magnet wire insulation, insulating papers, insulated wire and cable, rubber tape, solid filing, treating, encapsulating, and embedding compounds, varnishes and coatings, general methods of testing. Next slide. So, uh, for the start of the volume 10.01, uh, the standard D69-12 standard test methods for friction tapes. So, the scope of this standard, these test methods cover the methods and procedures for testing friction tapes. Such tapes consist of woven fabric sheeting that has been impregnated with an adhesive insulating compound it, and cut into rolls of narrow width. So these tapes are commonly used for protecting and binding in place. Insulation applied to joints of electrical wires and cables and for other mechanical purposes. So cotton friction tape has high strength and low stretch, making it ideal as a heavy-duty binding and harnessing tape. So cotton friction tape is intended for the following applications. One is to provide abrasion and cut-through protection on wire and cable splices. Next is to provide mechanical protection for rubber electrical tape. Next is provide bundling, binding and spot holding on wire harnesses. And last is provide protection on sharp edges to prevent scratching or cut through when applied over tool handles. It affects non-slip surface. So the test methods for this standard includes are as follows. So one is adhesion, age adhesion, braking strength, dielectric breakdown voltage, dimensions, discoloration of copper, and parallelism. So next page. Okay, so still under for the D69-12. Uh, for the properties of the friction tape. So the tape construction, it has to have a high quality cotton fabric coated on both sides with an electrical grade, solvent free, and rubber adhesive. For the material thickness, so it needs to be 14 milliliter positive negative 1. So for the color, it is black. Temperature operating 80 degrees Celsius or 176 Fahrenheit. 176 degree Fahrenheit. For the adhesion maximum, uh, it needs to be 15 inch per minute. Each addition maximum 15 inch, the same 15 inch per minute. So breaking strength 14 pounds per inch of width. For the breakdown voltage stated there 1000 volts. For the parallelism maximum, so 0.125 inch. For the core diameter 1 or 1 to 2 1 to half inch. For the shelf life inside storage, 2 years from date of manufacture. So the packaging. So each roll of tape shall be individually packaged in cellophane, plastic, or metal containers and legibly marked with the following information. One is the manufacturer's name, manufacturer's catalog number, and product description. Next slide is next standard. D115-17, or the standard test methods for testing solvent-containing varnishes used for electrical insulation. So the scope of this standard, these test methods cover tests for solvent-containing varnishes primarily intended to provide electrical, mechanical, and chemical protection for electrical equipment. So these methods include tests for control and performance as follows. One build for one is build. Build is used as an indication of the amount of varnish that will obtain on deep structure. So build will be affect will be affected by varnish properties such as viscosity, non-volatile content, weight loss, and curing characteristics, as well as geometry, composition, and temperature of deep service. So this method determines the total effect without attempting to separate these several factors. So for the procedure of uh, how this performance function. So prepare prepare three specimens using varnish as supplied. After the varnish has been conditioned at least 4 hours at the standard uh, laboratory atmosphere, deep drain and cure the specimens as described in 7.3. So reverse the specimens and apply a second coat. After curing the second coat, condition the specimens for 10 hours at the standard laboratory atmosphere. Next is measure the thickness in accordance with 7.3 along imaginary lines 40 and 100, 40, 100, and 160 millimeter. So from the deep line at one end of the specimen, make three measurements along each line in the 25 millimeter center section of the strip to avoid edge beads. Okay, so next is the dielectric strength. The dielectric strength of an insulating varnish is an important indication is supposed to be an important indication of its ability to withstand electric stress without failure. So this value does not correspond to the electric strength expected in service, but it is a numerical value which may be used for purchase by specification as an indication of quality. Quality for comparison of different varnishes and to a limited degree for design work when coupled with experience. So the comparison of dielectric strengths of a given varnish under various conditions is of considerable significance and provides much more information than is obtained by making the test under only one condition. So again, the procedure for dielectric strength uh, so to determine the dielectric strength in accordance with the test method, D149, using the short time test, increase the voltage from zero to breakdown at a uniform rate of 500 volts per second. Determine the dielectric strength immediately after removal of the specimens from the conditioning chamber. Using electrodes as described in 43.2, make all measurements at temperature of 23 positive negative 1 degree Celsius or 73.5 positive negative 2 degrees Fahrenheit. Next is the drainage. The drainage test is used for an indication of the amount amount of varnish retained on the surface and to some extent in the interior of a deep structure. So uh, let's go with the procedure. So Immerse a strip of sheet copper or brass with 38 millimeters of measurement in width, 200 millimeters in length, and 0.127 positive negative 0.008 millimeters in thickness in the varnish at 23 positive negative 1 degree Celsius. So immerse up to a line previously drawn across the strip, 25 millimeter from the top. So we draw the strip at the rate of 100 millimeter. So 100 millimeter per minute and allow to drain thoroughly at temperature while suspended vertically. So dry as described in 7.2.6 and 7.2.7. So measure thickness at points 25 and 150 millimeter respectively from the line to which the specimen was immersed. Next slide. So flash point approximates the lower temperature limit of flammability, or the temperature at which the concentration of the vapors of a liquid in air equals the lower flammability limits. So it is used in regulations for storage, transportation, handling, and use for of a liquid by U.S. regulatory agencies and state and local ordinances or codes. So, non-volatile matter, the percent of non-volatile matter is indicative of the amount of film-forming material available in the varnish. So, the percent of non-volatile matter is useful for control purposes during the manufacture and use of the varnish and in determining the uniformity of batches. Let's go already for the oil resistance. So the oil resistance test, when supplemented by practical tests, may be used to indicate the suitability of varnishes and magnet wire enamel applied to equipment in which the varnish is in contact with the insulating oils. So let's go with the procedure. For the procedure of the oil resistance, prepare the test specimens from uh, AWG AWG number 18, bare or film insulated, uh, annealed copper wire in accordance with the test method D2519. So prepare a minimum of 12 test specimens. Prior to immersion in the oil, set aside half of the test specimens for determination of bond strength. Vertically suspended, the other half of the specimens immersed in an insulating oil that meets the specification D3487. So other oils shall be permitted to be used for testing if uh, agreed to by customer and supplier. Heat the oil containing the test specimen for 72 hours at 105 to 110 degrees Celsius. Remove the test specimen from the hot oil and at the end of the heating period and allow it to drain in the vertical position for 1 to 1.5 hours. So test for bond strength, the retained samples, and the oil immersed samples under standard laboratory conditions at room temperature in accordance with the provisions of the test method 25 D2519. Next is the preparation of uh, test specimens, selection of substrate. The selection of the substrate is determined in part by application and in part by thermal class. Two types of substrates may be used, copper strip or glass cloth.
Copper strip in general not used for applications over 180 degrees Celsius due to oxidation.
So next slide. So specific gravity, the ratio weight of a unit volume
Of a sample as compared with the weight of the same unit volume of distilled water at 23 positive negative 1 degree Celsius. As specific gravity indicates the relative weight per unit volume of a varnish. So it is
it is use it is a useful test for control purposes. Determine the specific gravity of the varnish by using a wide mouth
pycnometer with 25 milliliter minimum capacity.
at 23 plus
Positive negative 1 degree Celsius are referred to test method D1475. Determine the specific gravity by dividing the weight of an equal volume of distilled water at the same temperature. A hydrometer is another method for determining this property. In accordance with the test method D287 or the method D1638. Temperature index. The temperature index determines the temperature index in accordance with at least two of the following tests.
test method
The 3251 or twisted pair using thermal life of
20,000 20,000 hours.
test method D 1932 curve electrode using thermal life of 25,000 hours. So test method D 3145 helical coils using thermal life of 20,000 hours.
It is recognized that there may be two or possibly more temperature indices for electrical insulating varnishes. The requirements of
The end use and performance are determining factor in selecting an appropriate temperature index.
next is time of drying. Drying time is useful for determining time required at specified conditions to cure the point when coated objects
Will have no surface tuck at a room temperature. So it does not measure cure or a varnish or possible softening at an elevated operating temperature.
So for the procedure, cover the panels at a temperature of 27
Then supposed to be positive negative, I think 27 positive negative 2 degrees Celsius with a layer of varnish that results in a final thickness as
prescribed in Part 3
of
of
the
this
standard.
standard. So the covering may be applied
Applied by dipping, spraying, or any suitable method. When specimens are prepared by dipping, the viscosity of the varnish shall be as specified
by the supplier. If necessary, the varnish is diluted to a suitable consistency. In any case, the specimen
and shall be allowed to stand drying. The specimen are
examined at a temperature of 27
positive negative 2 degrees Celsius. So a piece of filter paper is placed on the panel and the weight is placed on the paper in the vicinity of the center of the specimen, with the rubber disc interposed between the paper and the weight to distribute the pressure equally. After 1 minute, the weight and the disc are removed at the specimen and the
specimen is examined. So last is the varnish compatibility. 20 cubic centimeter
of the filtered varnish is poured into the stoppered measuring cylinder. 10 cubic centimeter of the
thinner described by the supplier is added after
after shaking vigorously. The mixture is allowed to rest
for some minutes.
if no cloudiness or separation is
Observe 5 centimeter of the thinner is added and the cylinder is shaken again and allowed to rest. So this is repeated until the mixture becomes cloudy or separation is observed. Next slide. Okay.
For last is the viscosity. So the viscosity measurement may be used to indicate the flowing characteristics of
A varnish. So viscosity is also useful for control purposes during the manufacture and use
use
of
of
a
a
varnish.
varnish. The procedure for viscosity is to determine the viscosity in accordance with the method D1638. So adjust the temperature of the varnish to 23 positive negative 1 degree Celsius and follow method D1638. Take precautions to avoid evaporation or formation of skin on the surface of the varnish.
State results in terms of absolute viscosity in centipoises. The test two specimen and report the mean value provided
The average deviation of a single observation
from the mean is not greater than
than 2%. So otherwise, check the instrument and method used to make additional tests until the average.
deviation from the mean does not exceed 2%. Okay, so next standard, the 149-09-2013. This is the standard test method
For dielectric breakdown voltage and dielectric strength of solid electrical insulating materials at
commercial
power
power.
frequencies.
So the scope of this standard, one is to test this
This
test
method covers procedures for the determination of dielectric strength of solid insulating materials at
commercial power frequencies under specified conditions. So unless otherwise specified, the test shall
shall
be
be
made
made
at
at
60
60.
Hz. However, this test method is suitable for use at any frequency from 25 to 800 Hz. At frequencies above 800 Hz, dielectric heating is a potential problem. So third is this test method
Is intended to be used
in conjunction
conjunction with any ASTM standard or other document that refers to this test method. References to this document need to specify the particular options to be used, for it is
suitable for use at various temperatures and in any suitable gaseous or liquid
surrounding medium. Fifth,
uh, this test method is not intended for measuring the dielectric
strength of materials that are fluid under the condition of test.
Sixth is the
This test method is not intended for use in determining intrinsic dielectric strength, direct voltage dielectric strength, or thermal failure under electrical test.
stress. Last is this test method is most commonly used to determine the dielectric breakdown voltage through the thickness of a test specimen. It is also suitable for use to determine dielectric breakdown voltage.
Voltage, along with the interface between a solid specimen and a gaseous or liquid surrounding medium. Next slide. Now is still in this the standard. So the dielectric strength of an electrical insulating material is a property of interest for any application where an electrical field will be present. In many cases, the dielectric strength of a material will be the determining factor in the design of the apparatus in which it is
To be used. So test made as specified herein
are suitable for use to provide part
of the
information needed for determining suitability of a material for a given application, and also for detecting changes of deviations from normal characteristics resulting from processing variables, aging conditions, or other manufacturing or environmental situations. This, ten, this test method is useful for process control, acceptance, or research testing. So results obtained by this test method can seldom be used directly to determine the behavior of a material in an actual application. In most cases, it is necessary that these results be evaluated by comparison with results obtained from other functional tests or from tests on the other materials, or both, in order to estimate their significance for a particular material. So, three methods for voltage application are specified in section 12. Method A, short time test. Method B, step-by-step test. And method C, slow rate of rise test. So, for method A is the most commonly used test for quality control tests. However, the longer time tests, methods B and C, which usually will give lower test results, will potentially give more meaningful results when different materials are being compared with each other. If a test set with a motor-driven voltage control is available, the slow rate of rise test, or the method C, is simpler and to preferable to the step-by-step test. The results obtained from methods B and C are comparable to each other. So next is specifying the use of this test, mes- test method shall also specify method of voltage application, voltage rate of rise, if slow rate of rise method is specified, specimen selection, preparation, and conditioning, surrounding medium and temperature during test, electrodes, whenever possible, the failure criterion of the current sensing element, and any desired deviations from the recommended procedures as given. So, if any of the requirements listed in 5.5 are missing from the specifying document, then the recommendations for the several variables should be followed. So, unless the items listed in 5.5 are specified, the test made with such inadequate reference to this test method are not in conformance with this test method. If the items listed in 5.5 are not closely controlled during the test, it is possible that these precisions stated in uh, 15.2 and 15.3 will not be obtained. Variations in the failure criteria of the current sensing element significantly affect the test results. Next slide. Next standard is the 150-11, where the standard test methods for AC loss characteristics and permittivity, or dielectric constant of solid electrical insulation. So for the scope of this standard, these test methods cover the determination of relative permittivity, precipitation factor, loss index, power factor, phase angle, and loss angle of specimens of solid electrical insulating materials when the standards used are lumped impedances. The frequency range that can be covered extends from less than 1 Hz to several hundred megahertz.
The test methods provide general information on a variety of
electrodes, apparatus, and measurement techniques. The reader should also
consult ASTM standards or other document directly applicable to the material to be tested. So permit permittivity. Insulating materials are used in general in two distinct ways. One is to support the insulate components of an electrical network from each other and from ground, and two is to function as the dielectric of a capacitor. For the first use, it is generally desirable to have a capacitance of the support as small as possible, consistent with the acceptable mechanical, chemical, and heat-resisting properties. A low value of
activity is thus desirable for the second use. It is
desire it is desirable to have a high value permittivity so that the capacitor is able to physically as small as possible. AC does. For both cases, as electrical insulation and as capacitor dielectric,
the AC loss generally needs to be small, both in order to reduce the healing of the material and to minimize its effect on the rest.
of the network. In high frequency application, a low value of low index is particularly desirable, since for a given value of loss index, the dielectric loss increases directly with frequency. In certain dielectric configurations, such as are used in terminating bushings and cables for tests, an increased loss, usually obtained from increased conductivity, is sometimes introduced to control the voltage gradient. In comparisons of materials having approximately the same permittivity, or in the use of material under such conditions that its permittivity remains essentially constant, it is potentially useful to consider the dissipation factor, power factor,
Phase angle or loss angle.
also correlation. When adequate correlating data are available, dissipation factor or power factor are useful to indicate the characteristics of a material in other respects, such as the electric breakdown, moisture content, degree of cure, and deterioration from any cause. However, it is possible that deterioration due to thermal aging will not affect the dissipation factor unless the material is subsequently exposed to moisture while the initial value of the dissipation factor is important. The change of dissipation factor with aging is often much more significant. Next slide. Next standard. Uh, the 202-17 or standard test methods for sampling and testing untreated vapor used for electrical installation. So the scope of the standard, these test methods cover procedures for sampling and testing untreated vapor to be used as an electrical insulator or as a constituent of a composite material used for insulating purposes. Untreated papers are thin, fibrous sheets normally laid down from a water suspension of pulp fibers, usually cellulosic, cellulosic, which may contain various amounts of non-fibrous ingredients and which are uh, calendared if required To obtain desired thickness and density, to, to obtain desired thickness and density. Nevertheless, these test methods are applicable generally, although not invariably, to papers formed by other means. To papers modified during or after formation by additions, and to papers given subsequent mechanical treatments such as prepping. As an electrical insulating and dielectric material, paper is considered untreated until it is subjected to the manufacturing process such as drying, impregnation, or varnish treatment. So the test methods given herein were developed specifically for papers having a thickness of 0.75 millimeter or less. A number of these test methods are also suitable for use on other materials such as pulps or boards, referred to test methods D3376 or methods D3394 to determine which tests are applicable to pulps or electrical insulating boards. In paper industry, some products in thickness or less than 0.75 millimeter are termed paperboard. Such products are included within the scope of these methods. So these test methods are applicable to flexible fibrous materials formed from suspensions of fiber in fluids other than water. So these mats may have thickness approaching 2 millimeters and may contain fiber that are natural, synthetic, organic, or organic fillers that are natural, synthetic, organic, or
Org- inorganic, and flexible polymeric binder materials.
next is the D229-13 are the standard test methods for rigid sheet and plate materials used for electrical installation. The scope of these standards. These test methods cover procedures for testing rigid electrical insulation normally manufactured in flat sheet or plate form. They are generally used as terminal boards, spacers, voltage barriers, and circuit boards. Use test method D619 or specification D710 for tests applying to vulcanized fiber. Some of the test methods contained in this standard are similar to those obtained in IEC 6089-3-2, which applies to rigid industrial laminated sheets based on thermosetting resins for electrical purposes. Next slide. Is still in that standard. The test methods appear in the following sections. So for the test, acetone extractable matter, uh, it can be seen in section 83 to 84 in test method D494. Arc resistance in section 47, test method D495. Ash in section 56 to 60 for in the standard, same as bonding strength in section 49 to 54 and burning rate of flame resistance in section 61 to 75 for this standard. So in compressive compressive strength in sections 25 in test method D695, conditioning in sections 4 D6 in test method D6054, dissipation factor in sections 34 to 40 in test method D669, dielectric strength in sections 28 to 33 in test method D149, expansion or linear thermal in section 76 in test method D696, flexural properties in sections 12 to 24 in test method D790, hardness or Rockwell in 55 in section 55 in test method D785, insulation resistance and resistivity in sections 41 to 46 in D257, permittivity in sections 34 to 40 in D1 in test method D150, resistance to impact in sections 26 in test method D256, tensile properties in sections 7 to 211 in test method D638, thickness for sections 5 to 6 in test method D374, tracking resistance in section 48 for D2 2132 warp or twist in sections 77 to 82 for this test method, and absorption in sections 27 for test method D570. Next slide. Okay, for the standard,
These 257-14 standard test methods for DC resistance or conductance of insulating
materials. So these test methods cover the direct current procedures for measurement of DC insulation resistance, volume resistance, and surface resistance. From such measurements and geometric dimensions of specimens and electrodes, both volume and surface resistivity of electrical insulating materials can be calculated, as well as the corresponding conductances and conductivities. For 2.1, insulating materials are used to isolate components of an electrical system from each other and from ground, as well as to provide mechanical support for the components. For this purpose, it is generally desirable to have the insulation resistance as high as possible, consistent with acceptable support for the uh, acceptable mechanical, chemical, and heat resisting properties. Since insulation resistance or conductance combines both volume and surface resistance or conductance, its measured value is almost useful when the test specimen and electrodes have same form as is required in actual use. Surface resistance of or conductance changes rapidly with humidity, while volume resistance and conductance changes slowly, with the total change being greater in some cases. So for the explanation of resistivity or conductivity, so it is used to predict indirectly the low frequency, dielectric breakdown, and dissipation factor properties of some materials. 2.3, all their dielectric resistances or conductances depend on the length of time of electrification and on the value of applied voltage, in addition to the usual environmental variables. This must be known and reported to make the measured value of resistance or conductance meaningful. So within the electrical insulation materials industry, the adjective apparent is generally applied to resistivity values obtained under conditions.
or arbitrarily selected electrification time.
Okay, so let's go to 2.5. Surface resistance or conductance cannot be measured accurately, only approximated, because some degree of volume resistance or conductance is always involved in the measurement. The measured value is also affected by the surface contamination, sur- surface contamination. Surface contamination and its rate of accumulation is affected by many factors, including electrostatic charging and interfacial tension. Next standard is the D295-12, or the standard test methods for varnish cotton fabrics used for electrical insulation. Brief explanation
For
for
the
the
scope, this test method covers procedures for the testing of varnished cotton fabrics and varnished cotton fabric tapes uh, to be used as
electrical insulation and are directly applicable to both straight cut and bias cut materials unless otherwise stated in the test method. So the procedures appear in the following order. So we have the breaking strength. The breaking strength of finished cloth and tape is of importance as measure of its ability to withstand reasonable pulling without
failure
failure
while
while
being applied. Now is so conditioning because the physical and electrical properties of most fabrics change with variations of their moisture content. It is
necessary to control this property at the time of testing in order to
attain
attain
reasonably good uh,
reproductive reproducibility of test values.
for
For
example,
example,
when cotton fabric absorbs moisture in
it
it
tends
tends to
to swell and increase in dimensions.
dimensions. And let's head down to dielectric breakdown voltage. The dielectric breakdown voltage of
Varnish cloth of tape insulating material is of significance for the following reasons. This test indicates the presence of defects in both cloth or varnish
in
in
part of the surface explored. Fourth methods of testing for dielectric breakdown voltage are given. The short time, step by step, uh, slow rate of rise, and long time voltage test.
so again the test methods that I
Usually
usually
discussed,
previously.
previously discussed.
So let's head down to the selection of test specimens. Select specimens for test. Uh, this, Selection of test specimens. Select specimens for test from portions of material free from defects. In the case
Case of rows
of
of
materials other than those packed in oil, remove the outer two layers of cloth or the outer six layers of tape and prepare test specimens from the remaining materials. In the case of oil packed tape, remove the outer layer
from
from
each
each
roll
roll
to
to
be
be
tested.
tested.
In the case of sheets
And tape strips, remove the outer six layers from of material
and
and
prepare
prepare
test
test
specimens
specimens
from the remaining. Okay, so the test resistance
test resistance of varnish
cloth
cloth
is influenced by construction of the base cloth and the direction of tear and cure of the varnish.
so this test method is applicable only to straight cut varnish cloth and to tape. not less than 2 and 1/4 inch or 64 millimeter wide. Next slide. And so thickness, the thickness test is necessary to determine whether the material meets specified tolerances for thickness. Thread count, together with the weight and width of the cloth is accepted as the common means for designating and identifying cloth constructions. Okay, so volume resistance. The volume resistance test on varnish cloths and tapes is a non-destructive test. This test is useful in quality control and to supplement the data derived from dissipation factor measurements. Next is the weight. Weight values are useful for estimating weight in designing electrical equipment containing a constituent part of varnish cloth or tape. Uh, so that's it for the weight. Let's head down for the next standard, the D348-13 or the standard test method for rigid tubes.
Used for electrical installation.
For the brief discussion of the scope of the standard, these test methods cover the testing of rigid tubes used in electrical installation. These tubes include many types made from fibrous sheets of basic materials such as cellulose, glass, or nylon in the form of paper, woven fabrics, or mats, banded together by naturals or synthetic resins or by adhesives. Such tubes include vulcanized fiber and thermosetting laminates, as well as tubes made from cast molded or extruded natural or synthetic resins with or without fillers or reinforcing materials. Let's go on for the next page. Okay. Next is the standard D349-13 or the standard test for laminated round rods used for electrical installation. For the scope of this method, of this standard, this
This test method covered the procedures for testing rigid round rods
used
using
in electrical installation. These round rods include many types from made from fiber sheets of basic materials such as cellulose, glass, wait, it's the same as before. Okay, so katulad nga lang siya nung kanina. Uh, Next standard is the D350-13 or the standard test methods for flexible threaded sleeving used for electrical installation. These test methods cover procedures for testing electrical insulating sleeving comprising a flexible tubular product made from a woven
textile fiber base, such as cotton, rayon, nylon, or glass. Thereafter impregnated and coated I or N
with a
suitable dielectric
material. Next
Next,
standard is the D351-14 or the standard classification for natural muscovite, black mica,
and tints based on visual quality.
for the scope of the standard.
This classification covers the determination of
Commercially available natural muscovite, black mica, and
is intended to be independent of the basic color of the mica or its source.
Muscovite mica is characterized by having an optical axial
Angle between 50 and 75 degree angle and has a weight loss when heated for 5 minutes at 600 degrees Celsius, not exceeding 0.2% based on the weight after drying at 120 degrees Celsius.
So the visual system of classifi- classifying the quality of natural muscovite mica covered by this specification is based on upon relative amounts of visible foreign inclusions, such as air bubbles, stains, and spots, in combination with relative amounts and types of waviness, as well as other physical properties. In this system, a perfectly clear, transparent, flat specimen of mica is the visual standard for perfection.
Increasing amounts of visual defects lower the visual quality, and a total of 13 levels of uh,
Visual quality are covered by this standard. This method of classification, generally known as the Bengal India system, is purely qualitative and is entirely dependent on personal opinions and judgment. Okay, so I think that's it for this standard. Next page. Alright, so standard D37 or
D37 4M-16.
or the standard test method for thickness and solid electrical insulation. For the scope of this standard, these test methods cover the determination of the thickness of several types of solid electrical insulating materials, employing recommended techniques. Use the standard test methods except as otherwise required by a material specification. Some electrical properties such as dielectric strength vary with the thickness of the material.
Determination of certain properties such as relative permittivity and volume resistivity usually require a knowledge of the thickness.
Design and construction of electrical
Machinery
machinery
require that the thickness of insulation be known.
for the standard D470-13 or the standard test method for cross-link installations and jackets for wire cable. So for the scope of this standard, this test method cover procedures. This test method cover procedures for testing cross-link insulations and jackets for
Wire and cable to determine the test to be made on the particular insulation or jacket. Refer to product specification for that type. This test method do not apply to the class products known as flexible cords. In many instances, the insulation or jacket cannot be tested unless it has been formed around the conductor or cable. Therefore, tests
are done on insulated jacketed
wire
wire
or cable.
in this test method solely to determine the relevant property of the insulation or jacket and not to test the conductor or the completed table. Okay, in the picture is the procedures appear in the following sections for the standard test methods for cross-link installations and jackets for wire and cable. So, next page na tayo. Okay, so standard D495 or 14 or the standard test method for high voltage, low current, dry arc resistance of solid electrical insulating. Just wait. For the scope of this standard, this test method covers in a preliminary fashion the differentiation of similar materials, resistance to the action of a high voltage, low current arc close to the surface of insulation when a conducting path is formed causing the material to become conducting due to the localized thermal and chemical decomposition and erosion. Okay, so the usefulness of this method is very severely limited by many restrictions and qualifications, some of, some of which are described in the following paragraphs and in Section 5. Generally, this test method shall not be used in material specifications whenever possible. Alternative test methods shall be used and their development is encouraged. Next is this test method will not, in general, permit conclusions to be drawn concerning the relative arc resistance rankings of materials that are potentially subjected to other types of arcs. For example, high voltage and high currents, and low voltage and low or high currents. Okay, let's go to 2.3. For general types of failure have been observed. Wait. Let's go to 2.2. In order to distinguish more easily among materials that have low arc resistance, the early stages of this test method are mild, and the later stages are successively more severe. The arc occurs intermittently between two electrodes resting on the surface of this specimen in normal or inverted orientation. The severity is increased in the early stages by successively decreasing to zero the interval between flashes of uniform duration and in later stages by increasing the current. Now is for general types of failure that have been observed. Many many inorganic dielectrics become incandescent, whereupon they are capable of conducting the current. Upon cooling, however, they return to their earlier insulating condition. So next is some organic compounds burst into flame without the formation of a visible conducting path in the substance. Next, if the others are seen to fail by tracking, that is a thin wiry line is formed between the electrodes. Last is the fourth type occurs by carbonization of the surface until sufficient carbon is present to carry the current. Next slide. Okay, next standard is the D619-14 standard test methods for vulcanized fiber used for electrical insulation. For the scope of the standard, this test methods details the standard procedures for testing certain properties of vulcanized fiber sheets, tubes, and rods of such grades as can be. Oh yeah. Okay, so last for me, I think. This test method details the standard procedures for testing certain properties of vulcanized fiber sheets, tubes, and rods of such grades as can be used for electrical installation. Arc resistance, ash content, bond strength, bursting strength, compressive strength, conditioning, density,
dielectric strength, dimensional measurements, flammability.
flexural strength, silica content, etc. Uh,
Are among the properties that these test methods shall be able to examine. Next standard, the
D668-12 or the standard test methods for measuring dimensions of rigid rods and tubes.
used for electrical insulation. These test methods cover the measurement of the dimensions.
Of all rigid rods and tubes used as electrical insulation. The
Limitations
limitations
imposed being those of
size range of the more common forms of measuring instrument used. Where the number of tests to be made
or the specifications
covering the rod or tube
justify its use. It is acceptable to use an accurately calibrated go and no go gauge.
of suitable size. And these test methods are used to measure the dimensions of the rod or tube to determine conform, conformance with specification of full lengths or cuts or cut lengths. The measurements can also be used for manufacturing control, determination of uniformity, dimensional stability, and physical and electrical properties of the rods and tubes. Next standard, the D689-17 are the standardized method for internal tearing resistance of paper. This test method measures the force perpendicular
To the plane of the paper required to tear multiple sheets of paper through a specified distance. After the tear has been started, using an Elmendorf type tearing tester, the measured results can be used to calculate the approximate tearing resistance of a single sheet. In the case of
tearing a single sheet of paper.
the tearing resistance is measured directly. So this test method is not suitable for determining the cross-directional tearing resistance of highly directional boards and papers.
This test method is widely used within the paper industry in conjunction with other tests of strength as predictor of end-use performance of a wide range and grades of papers. Next slide. Alright, so standard D709-17 or standard specification for laminated thermosetting materials.
This specification covers laminated thermosetting materials
Consisting of two or more two or more plies or layers.
of reinforcing material bonded by a thermosetting synthetic resin. Examples of such reinforcement are cellulose paper, cotton fabric, glass fabric, and synthetic fiber fabrics. These materials are available in the form of sheets, rolled and molded tubes.
And molded rods. The value stated. So next standard is the D70-13 or the standard specification for vulcanized fiber sheets, rods, and tubes used for electrical installation. The
Specification covers vulcanized fibers in sheet, rod, round rod, and round tube forms of bone, commercial and electrical insulation grades. Fibers shall be tested appropriately and consequently conform to specified color, oops, chemical composition, flexural strength, impact strength, tearing strength, compressive strength, water absorption, dielectric strength, bursting strength, density, Rockwell hardness, and dimensional and size requirements. Next standard is the D748-14 standard specification for natural black mica and mica films suitable for use in fixed mica dielectric capacitors. Uh, this specification covers the electrical, visual, and physical properties of natural blocks and films made from mica that are suitable for use in fixed mica capacitors. The materials under this specification are of three forms and four classes. Processes. Samples should be taken wait, and tested according to the test methods prescribed here. All samples should adhere to the specified values of conducting path, path, Q value, dielectric constant, weight loss on heating, thickness, uniformity, temperature coefficient, and capacitance at retrace, and amount of air inclusions, waves, cracks, tears, pinholes, stones, buckles, and ridges. The properties included in this specification are those required to identify the types of natural black mica and mica films, cut and uncut, suitable for use in the manufacture of fixed mica dielectric capacitors. It is possible that other requirements will be necessary to identify particular characteristics. This will be added to this specification as their inclusion becomes generally desirable, and the necessary data and methods become available. It is possible that natural black mica and mica films that do not conform to the requirements of the specification for capacitor use are capable of meeting the requirements for other critical electric installation purposes. Next slide. Next standard. D876-13 standard test methods for non-rigid vinyl chloride polymer tubing used for electrical insulation. Scope of this test method cover the testing of general purpose grade grade A low temperature grade B and high temperature grade C. Two non-rigid vinyl chloride polymer tubing or its copolymers with other materials for use of electrical insulation. For the purpose of these test methods, non-rigid tubing shall be tubing having the initial elongation in excess of 100% at break. So next standard is the D922-11 or the standard specification for non-rigid vinyl chloride polymer tubing. The specification covers three grades of non-rigid tubing of vinyl chloride polymer or its copolymers with other materials for use in electrical insulation. Uh, Clear, transparent, black, white, yellow, green, blue, and red shall be considered standard colors. Colors other than these shall be considered special. Dimensional requirements to which tubing shall adhere are inside diameter, wall thickness, and commercial lengths. The tubing shall also conform to physical and electrical requirements as follows: flammability, tensile strength, effect of elevated temperatures, ultimate elongation after immersion in oil, brittleness, temperature, penetration resistance, volume resistivity, dielectric breakdown at high humidity, strain relief, and corrosive effect. Our next standard is the D982-16 or the standard test method for organic nitrogen in paper and paperboard. This test method covers the determination of nitrogenous organic materials in paper and paperboard, which typically are used to reduce the thermal degrade- degradation of the cellulose in the paper and paperboard. The nitrogen determination by this method does not include the nitrogen in nitro compounds. Nitrate, nitrates, nitrates, azohydrazine, cyanide, or pyridine ring type compounds, none of which are normally found in paper or in paperboard. There is no known modification of the method that is applicable to all nitrogenous compounds. Next slide. Next slide. Our next standard is the D1000-17 or the standard as methods for pressure sensitive adhesive coated tapes used for electrical and electronic applications. These test methods cover procedures for testing pressure sensitive adhesive coated tapes to be used as electrical insulation. These tapes are classified as follows. So for class 1, non-elastomeric backings made from materials such as paper, flat, or crepe, fabric uncoated or coated, cellulose ester films, polyethylene terephthalate or polyester films, uh, fluorocarbon polymer films, composite filament films, polyamide polyamide films, and combinations thereof. For class 2, elastomeric backings that are characterized by both high stretch and sustained substantial recovery. These backings are made from materials such as vinyl chloride and copolymers, vinylidene chloride and copolymers, and polyethylene and copolymers. Test laminates of class 1 and class 2 backings according to class 1 test methods. So the procedures appear in sections indicated below and in alphabetical order. But I think I'm not gonna read it. So again, these are the procedures appear in the sections indicated below in alphabetical order for this standard. Okay, so let's go to next slide already. Okay, so D1039-16 standard test methods for glass banded mica used as electrical insulation. This test method covers the evaluation of the characteristics of glass banded natural or synthetic mica materials intended for use as electrical insulation. Glass banded mica materials are commercially available in both injection molded and compression molded types. These methods are applicable to both types except for tensile strength methods.
The test methods appear in the following sections: arc resistance, compressive strength, conditioning, dielectric strength, dissipation factor, heat distortion temperature, impact resistance, modulus of rupture, permittivity, porosity, resistivity, volume and surface, Rockwell hardness, specific gravity, specimens tensile strength, terminology, thermal conductivity, thermal expansion and thickness. Alright, let's go to the next standard. The D1047-16 or the standard specification for polyvinyl chloride jacket for wire and cable. So the specification covers a durable general-purpose thermoplastic jacket made from polyvinyl chloride or the copolymer of vinyl chloride and vinyl acetate for use in wires and cables as specified minimum installing temperature. The jacket shall meet specified values of the following physical and electrical properties: unexposed or unaged tensile strength and elongation at rupture, tensile strength and elongation at rupture after air, oven, aging, and oil immersion tests, heat distortion, heat shock, cold bend, surface resistivity, and view bend discharge at required cable insulation, AC test voltage. Next slide. Next standard is the D1082-17 standard test methods for dissipation factor and permittivity. Dielectric constant. I brief scope of the standard. This test method covers the determination of the dissipation factor and the relative permittivity of natural black mic having thicknesses between 0.007 and 0.030 inch and mica films or capacitor splits between 0.0008 and 0.004 inch in thickness. So the dissipation factor of natural muscovite mica, as determined by by this test method, is of practical importance as a measure of the electrical energy loss as heat in the mica serving as the dielectric substance of capacitors, or in other application in which the electric field is applied perpendicular to the plane of cleavage. The dissipation factor is particularly important in applications using mica at radio frequencies and in some less expensive audio frequency applications. This test method is suitable for specification acceptance and dielectric loss control tests. Next standard is the D1351-14 or the standard specification for thermoplastic polyethylene insulation for electrical wire and cable. So this specification covers thermoplastic polymer insulation consisting substantially of polyethylene considered suitable for use of electrical wire or cable with specified maximum conductors sizes that will be used for continuous operations uh, wait, operation at specified conductor temperature and maximum voltage rating for power application or series lighting. Since the insulation material cannot be tested unless it has been formed around a conductor, tests shall be done on insulated wire and or cable in the specification are solely to determine the relevant property of the insulation materi- material and not to test the insulated conductor or completed cable. Material shall conform to physical properties as to
unaged tensile strength, and elongation at rupture. Tensile strength and elongation at rupture after the oven aging, and absorption coefficient and insulation thickness. Insulation shall also be tested for their electrical performance in terms of AC and DC voltage, partial discharge, and uh, insulation resistant. Next slide. I. D1 for 58-13 standard test methods for fully cured silicon rubber coated glass fabric and tapes for electrical insulation. This test method covers procedures for testing fully cured silicon rubber coated glass fabric and tapes to be used for electrical installation. The test procedures for following test methods are detailed. 1. Breaking strength. 2. Breaking strength and after increasing. Dielectric 3. Dielectric breakdown voltage. 4. Dielectric proof voltage. 5. Dissipation factor and relative permittivity. 6. Thermal endurance. 7. Thickness. 8. Thread count. 9. Volume resistivity. And 10. Weight. The procedures for sampling of fabric rolls, fabric sheets, tapes, and strips, and test specimens preparation and conditioning are given. The test apparatus report requirements and precisions and bias for each test are provided. The drum type tripping device and creasing apparatus for breaking strength tests are illustrated. Voltage stress test shall be done for dissipation factor and relative permittivity and volume resistivity tests. Next standard is the D1675-30 of 2011, or the standard test methods for polytetrafluoroethylene tubing. This the test methods in this standard are considered important to characterize polytetrafluoroethylene tubing. They are intended primarily for but not limited to polytetrafluoroethylene tubing. Variations in these methods or alternate contemporary methods of measurement may be used to determine the values of the properties in this standard provided such methods ensure quality levels and measurement accuracy equal to or better than those prescribed herein. It is the responsibility of the organizations using alternate test methods to be able to demonstrate the condition. In cases of dispute, the method specified herein shall be used. Provisions for alternate methods is necessary because one, the desire to simply procedures for specific applications, and two, the desire to eliminate redundant testing and use data generated during the manufacturing process control, including that generated under statistical process control (SPC) conditions, using equipment and methods other than those specified herein. An example would be the use of laser micrometers or optical compar- comparators to measure dimensions. Next slide.
So the D1676-17 are standard test methods for film insulated magnet wire. So these test methods cover procedures for testing film insulated magnet wire that is used in electrical apparatus. These test methods are intended primarily for the evaluation of the electrical insulating materials used. The intent in is that these test methods be used except were modified by the individual specification for particular applications. These test methods present different procedures for evaluating given properties for round, rectangular, or square copper or aluminum film insulated magnet wire. The test methods appear in the following sections: bond strength, burnout, chemical resistance, coefficient of friction. Okay, so continuity, DC high voltage continuity, DC low voltage, completeness of cure, cathode temperature, thermoplastic flow, dielectric breakdown, AC voltage, dielectric breakdown, AC voltage after bending, dielectric breakdown, AC voltage at elevated temperatures, breakdown, AC voltage after conditioning in refrigerant atmosphere, dimensional measurement, dissipation factor, electrical resistance, elongation, extractable refrigerant, film adherence, and flexibility for mobility. Uh, that's next slide. For next standard, the D1677-17 standard methods for sampling and testing untreated mica paper used for electrical insulation. Uh, the, this test method cover procedures for sampling and testing untreated mica paper. So, these methods cover procedures for sampling and testing untreated mica paper to be used as an electrical insulator or as a constituent of a composite material used for electrical insulating purposes. Accurate determination of thickness is important for identification purposes. Thickness is related to weight and must be known in order to calculate apparent density and the dielectric strength. Thickness variation affects the quality of roll winding and is used in judging the uniformity of mica paper, particularly with respect to the dielectric breakdown voltage, impregnation time, and thickness of the product. So we so the next standard next standard is the B1711-15 standard terminology relating to electrical insulation. Uh, This terminology is compilation of technical terms used in conjunction with testing and specifying solid electrical and electronics insulating materials in standards under the jurisdiction of Committee T-9 on Electrical and Electronic Insulating Materials. It is intended that all the definitions in this terminology are identical to the definitions of the same terms as printed in standards or originating technical subcommittees. Subcommittees with the exceptions of deletion of any part of the discussion included in other standard that refers specifically to the use of a term in the standard.
Figure numbers and corresponding references.
References and the terminology, parenthetical addition of a reference to one or more technical standards in which the term is used, and the year which the term was added to the compilation. I'll state symbols may be included as part of their representation of terms where appropriate. It is not intended that this terminology include descriptions of terms or symbols except as noted in 1.3. Acronyms and abbreviations referring directly to defined terms may be included. Next is the standard D1830-17 are the standard test method for thermal endurance of flexible sheet materials used for electrical insulation by the curved electrode method. Oh, uh, this test method provides a procedure for evaluating thermal endurance of flexible sheet materials by determining electrical breakdown voltage at room temperature after aging in air selected elevated temperatures. Thermal endurance is expressed in terms of temperature index. This test method is applicable to such solid electrical insulating materials as coated fabrics, dielectric films, composite laminates, and other materials where retention of flexibility after hearing aging is of major importance. This method is not intended for the evaluation of rigid laminate materials nor for the determination of thermal endurance of those materials, which are not expected or required to retain flexibility in actual service. Next slide. Our next standard is the D167-13 standard specification for copper-clad thermosetting laminates for printed wiring. This specification covers the 12 grades of thermosetting laminate with copper foil cladded to on both surfaces. These combination forms are intended primarily for use in fabrication and printed wiring or circuit boards. The laminate shall meet the following requirements: peel strength after solder float and at elevated temperature conditions, lengthwise and crosswise flexural strengths, flammability rating, water absorption, volume resistivity, dielectric breakdown parallel, parallel to laminations, dissipation factor, and permittivity, warp or twist, and blistering requirements shall also be tested for conformance. Next standard, the D1868-13 standard as method for detection and measurement of partial discharge fault pulses in evaluation of insulation system. This
Test method. This
test method covers the detection of measurement of partial discharge pulses at terminals of an insulation system under an applied test voltage,
including the determination of partial
charge, inception, and extinction voltages as the test voltage is raised and lowered. The test method also useful in determining quantities such as apparent charge and pulse repetition rate together with such integrated quantities as average current, quadratic rate of quadratic rate and power. The test method is useful for test voltages ranging in frequency from 0 to approximately 2000 Hz. So next standard is the D1932-13 or the standard test method for thermal endurance of flexible electrical insulating varnishes. This test method covers the determination of the relative thermal endurance of flexible electrical insulating varnishes by determining the time necessary at elevated temperatures to decrease
the electric breakdown of the varnish to arbitrarily
selected value when applied to a standard glass fiber fabric. This test method does not apply to varnishes that lose a high percentage of their dielectric breakdown voltage when flexed before elevated temperature exposure as prescribed in the screening test. Examples of such varnishes are those used for high-speed armatures and laminated structures. Also, this test method is not applicable to varnishes which start sufficiently during thermal elevated temperature exposure so that they cannot be tested using the curved electrode assembly.
next slide.
Okay, so D to 2131-97 of 2016 standard classification for natural muscovite microsplittings. The specification covers the determination of muscovite microsplittings of standard commercial grades and specifies the maximum allowable physical defects for each grade. It is applicable to commercially available natural muscovite microsplittings regardless of the basic color of the mica or its source.
This specification covers 13 grades
Of microsplittings based on size and form classification.
mica splitting shall meet the
Specified physical property requirements such as size, thickness, defects,
and absence of
any foreign matter.
were specified the visual quality shall conform to the description of the visual category specified such as
V-1,
V-1, V-2, V-3,
V-4, V-5, 5,
V-5, V-5.1, V-6,
V-6, V-7, V-8, V-9, V-10, V-11, and V-12.
the method of sampling of mica splittings in book form and loose with powder form are specified and method of circulating defect percentage is given.
Next, the standard D2132-12 standard test method for dust and fog tracking and erosion resistance of electrical insulating materials. Uh, Method, it
It is possible that electrical insulation in service
will fail as result of cracking, erosion, or combination of both. If exposed to high relative
humidity and contamination environments. This is particularly true of organic insulations in outdoor applications where the surface of the insulation becomes
contaminated by deposits of moisture and dirt. For example, coal dust or salt spray. This
this test method is an
accelerated test that stimulates extremely severe outdoor contamination.
it is believed that the most severe conditions are likely to be encountered in outdoor service in the United States will
Be relatively mild compared to the conditions specified in this test method. Next standard is the D748-14 standard specification for natural black mica and mica films suitable for use in fixed mica dielectric capacitors. The specification covers the electrical, visual, and physical properties of natural blocks and films made from mica that are suitable
for
for use
use
in fixed mica
electric
dielectric capacitors.
capacitors.
The materials
Under this specification are the three forms
and
for
for
classes.
classes. Samples should be taken and tested according to the test
Test methods
prescribed
prescribed
here
here. All samples should adhere to the specified values.
of conducting path, Q value, dielectric constant, weight loss, on heating, or, thickness, uniformity, temperature,
Temperature coefficient of capacitance and uh, retrace and amount of inclusions, waves, cracks.
tears, pinholes, stones, buckles, and ridges. Next slide. For the next slide will be reported by my other member is John Paulo Montero.
Okay, for the next standard, it is the DA28-16 standard test method for tensile properties of paper and paperboard using constant rate of elongation apparatus. So, this test method covers procedures for determining tensile properties of paper and paperboard. The procedures given in this method are used for the constant rate of elongation tensile testing equipment and as such are able to be used with instruments designed for either vertical or horizontal operation and whether manually operated or computer controlled. These procedures are applicable for all types of paper, paperboard, paper products, and related materials within the measurement limitations of the equipment used. They are not used with combined corrugated board. Properties able to be determined using this test method include tensile strength, stretch, tensile energy absorption, tensile stiffness, breaking length, and tensile index. Next standard is the D902-12 standard test methods for flexible resin-coated glass fabrics and glass fabric tapes used for electrical insulation. The electrical properties of resin-coated glass fabrics are affected by their temperature and moisture content. For the reason it is necessary to control these properties for a specified time immediately prior to testing in order to attain reasonably good reproducibility of test values. This time of exposure to the conditioning atmosphere must be long enough to permit the test specimen to reach a relatively stable value. Usually, the moisture content of these materials has little effect on the mechanical properties. These test methods cover procedures for the testing of resin-coated glass fabrics and glass fabric tapes to be used as electrical insulation. The warp threads in fabrics are the threads that are parallel with the length dimension as manufactured. The next standard is D982-16 standard test method for organic nitrogen in paper and paperboard. The scope of this standard is the purpose of this test method is to determine the amount of organic nitrogen present with a sample of electrical insulation paper or paperboard. Nitrogen content is used to determine if the paper or paperboard has been chemically treated to withstand higher than standard temperatures. The next standard is Next standard is D1361 specification for electrical insulating paper and paperboard. Sulfate craft layer type. This specification covers electrically insulating unbleached sulfate paper and paperboard used as layer insulation in coils, transformers, and other similar apparatus. The materials may also be used as turn insulation, slat liners, wedges, paste insulation, and separator papers in stranded wire cable constructions. This specification does not include tissue for manufacture of capacitors. Other commonly used terms for the materials include soft coil wrap, dense coil wrap, craft coil insulation, dry finish craft, and water finish craft. The materials covered in this specification are classified into four types according to density range and normal thickness and should conform to the required values of ash content, alcohol soluble material content, aqueous extract conductivity, water soluble chloride content, fiber composition, moisture content, hydrogen ion concentration, pitch tensile strength, the electric breakdown voltage, and conducting paths. So now we're going to proceed with volume 10.02 electrical insulation D2519. So the first standard for this volume 10.02 is D2519-07-2012. Standard test method for band strength of electrical insulating varnishes by the helical coil test. So this test method covers determination of the band strength of an electrical insulating varnish when applied to a helical coil. The helical coil can be made from bare minimum or copper wire or from film or fiber insulated magnet wire. Helical coils made from bare aluminum or bare copper wire will yield values of band strength for the varnish when applied for bare metal conductors. The use of film or fiber insulated magnet wire will show values for the particular combination of insulation and varnish. So next one is the D2520-13 standard test methods for complex permittivity, dielectric constant of solid electrical insulating materials at microwave frequencies and temperature to 1650 Celsius. These test methods cover the determination of relative complex permittivity, the electric constant, and dissipation factor of non-magnetic solid dielectric materials. Test method A is for specimens precisely formed to the inside dimension of waveguide. Test method V is for specimens of specified geometry that occupy a very small portion of the space inside the Resonant cavity. Test method C, used for resonant cavity with fewer restrictions or specimen size, geometry, and placement for the test methods A and B. It's designed calculations for such components as transmission lines, antennas, domes, resonators, phase shifters, and etc. Require knowledge of values of complex permittivity at operating frequencies. The related microwave measurements substitute distributed field techniques for low frequency lamp circuit impedance techniques. For the information of the significance of permittivity is contained in test methods D150. These test methods are useful for the specification acceptance, service evaluation, manufacturing control, and research and development of ceramics, glasses, and organic dielectric materials. So we're going to proceed with the next standard. It is the D2633-13A standard test methods for thermoplastic installations and jackets for wire and cable installations. So the test methods do not apply to the class of products known as flexible cores. Material consisting substantially of polyethylene insulation or jacket material created to These test methods do not apply to the class of products known as flexible cords. The electrical tests on insulation and water absorption tests do not apply to the class of products having a separator between the conductor and the insulation. These methods pertain to insulation or jacket material for electrical wire and cables. In In many instances, the insulation or jacket material cannot be tested unless it has been formed around the conductor or cable. Therefore, tests are done or insulated on jacketed wire or cable in these test methods solely to determine the relevant property of the insulation or jacket material and not to test the conductor or completed cable. So the next standard is D2655-17 standard specification for cross-link polyethylene insulation for wire and cable rated to 0 to 1000 volts. So the specification covers cross-link polymer insulation material consisting substantially of polyethylene or polyethylene copolymer for electrical wires and cables in conductor, suitable for continuous use on power cables in wet and dry locations, having specified sizes and operating at specified voltage ratings and conductor temperatures. Materials covered. Next slide pala, next slide. Wait lang. Next slide nga pre. Balik mo, balik. Wait lang. Sa ano pa lang pre dito, dito 65613. Pangalawang slide sa volume 10.02. Yan. Yan na ako. Wait lang. Ay, ito muna pala ako sa dito 6313A. Tapos na tao dito. So, these test methods, yan. These test methods pertain to insulation or jacket material for electric wire cables. In many instances, the insulation or jacket material cannot be tested unless it has been formed around a conductor or cable. Therefore, tests are done on insulated jacketed wire or cable in these test methods solely to determine the relevant property of the insulation or jacket material and not to test the conductor or completed cable. So next is tapos na pala ako dito sa D26517. Dito na ako sa 13 pala tama. So D2656-13 standard specification for cross-linked polyethylene insulation for wire and cable rated 2001 to 35,000 volts. So this specification covers our cross-linked polyethylene insulation for electric wire and cables for conductor sizes 8 AWG 8.37 millimeters squared and larger. The base polymer of this insulation consists substantially of polyethylene. The partial discharge, AC voltage, insulation resistance, and DC voltage shall be tested to meet the requirements prescribed. The accelerated water absorption, permittivity, and dissipation factor, U-bend discharge, and surface resistivity shall be tested to meet the requirements prescribed. The heat distortion and percent hot creep and percent hot set shall be tested to meet the requirements described. So next slide, D2671-13, standard test methods for heat shrinkable tubing for electrical use. These test methods include most of the important tests used to characterize heat shrinkable tubing. They are intended primarily for but not limited to extruded heat shrinkable tubing. It is acceptable to use variations in these test methods or alternate contemporary methods of measurement to determine the values for the properties in the standard provided. Such methods ensure quality levels and measurement accuracy equal to or better than those prescribed herein. So it is the responsibility of the organizations using alternate test methods to be able to demonstrate this condition. In cases of dispute, the methods specified herein shall be used. So next standard is D2686-06 2012 standard specification for polytetrafluorotylene back pressure sensitive electrical insulating tape scope. This specification establishes the manufacture of and requirements for two types and two grades of electrical insulating tape consisting of a polytetrafluorethylene (PTFE) film coated on one side with a pressure sensitive adhesive. Type 1 is standard backing, while type 2 is bondable backing tape. Grades are designated based on backing thickness. Besides standard lengths, widths, and thickness, tape shall also conform to other requirements such as breaking strength, elongation, addition to steel and backing, dielectric breakdown, and high humidity insulation resistance. So next slide. Next standard is D2754-10 2016 standard specification for high temperature glass cloth pressure sensitive electrical insulating type. This specification covers the requirements for two types of high temperature electrical insulating tape consisting of glass cloth coated on one side with a pressure sensitive adhesive. Type 1, which is subdivided into two grades, grade A and B, according to thickness, is woven glass cloth with silicone adhesive. Type 2, on the other hand, is a woven glass cloth impregnated with polytetrafluoroethylene, silicone adhesive. Tape shall undergo tests that shall examine their conformance to the following requirements: standard thickness, width, and length, breaking strength, the electric breakdown, adhesion strength, both to steel and backing, high humidity insulation resistance, and wind force, and accelerated aging. Next standard is D2802-14 standard specification for ozone resistant ethylene alkene polymer insulation for wire and cable. So the specification covers an ozone resisting cross-linked rubber insulation compound for electrical wires and cables. The polymer shall consist substantially of ethylene alkene copolymer EAM or ethylene alkene terpolymer EADM. This polymer type includes ethylene copolymer, EPM ethylene propylene terpolymer EPDM. The cross-linked insulation shall conform to the requirements for physical properties specified. Tests shall be performed in accordance to the following test methods: AC voltage withstand test, insulation resistance, DC voltage withstand test, capacitance and dissipation factor, partial discharge level test, accelerated water absorption, and ozone resistance. Next standard is D2861-14 standard test methods for flexible composites of copper foil with dielectric film or treated fabrics. This test method These test methods covers procedures for testing flexible materials consisting of copper foil combined with either the electric film or with treated or impregnated fabric to form flexible composites used in the manufacture of flexible or multilayer circuitry or both. The procedures appear as follows: conditioning, flex life of the composite, pre-strength of the composite, specimen preparation, strain relief due to etching, testing of the electric portion of the composite. So next standard is the D2902-00-2013 Episode 1 standard specification for fluoropolymer resin heat shrinkable tubing for electrical insulation. This specification applies to flexible fluoropolymer resin heat shrinkable extruded tubing made from tetrafluoroethylene resin, copolymer of tetrafluoroethylene, and hexafluoropropylene (FEP), and from perfluorofloxy (PFA) resin for use as electrical insulation. This specification covers three types of tubings, namely Type 1 tubing, normally made by paste extrusion, and Type 3 tubings, normally made by melt extrusion. The finished compound shall be free of foreign matter other than intended formulation additives. The material shall condone to the specified chemical and physical property requirements such as restricted shrinkage, specific gravity, longitudinal change, tensile modulus at elongation, volume resistivity, the electric breakdown voltage, heat resistance, low temperature flexibility, and melting point. The dimensional requirements after unrestricted shrinkage such as inside diameter, wall thickness, and stack lengths are specified. The sampling and test methods to determine conformance to the specified requirements are given. Next slide. Wala pa pala, pre. Last standard sa last slide. So, next standard is D2902-00-2013. Ay, wait lang. Oo nga pala. Next slide. Sorry. Dodoling na ako eh. Next slide na yan, pre. Yan, yan. Next slide is D2903-11 standard specification for cross-link chlorinated polyli- polyolefin heat shrinkable tubing for electrical insulation. This specification covers the manufacture, testing, and property requirements of two types of flexible cross-link chlorinated polyolefin heat shrinkable tubing used for electrical insulating purposes. It is supplied in an expanded form and will shrink it to the specified diameter when heated. Type 1 tubing is used for normal operating temperatures, while Type 2 tubing is used for extended operating temperatures. The finishing compound shall be free of foreign matter other than antioxidants, flame retardants, processing aids, cross-link agents, pigments, or other additives inappropriate. The final tubing shall be extruded, cross-linked, and then expanded to the required dimension. Specimens shall be sampled and tested accordingly for the following properties: corrosion by copper mirror and copper contact test, solvent resistance by immersion in grade JP for fuel, lubricating oil or hydraulic fluid, sodium chloride solution, anti-icing fluid, and aviation gasoline, flammability, time of burning and burning distance, water absorption, and tensile strength, ultimate elongation, and weight increase. Next slide is D3004-08 2013 standard specification for crosslink and thermoplastic extruded semiconducting conductor insulation shielding materials. This specification covers crosslink and thermoplastic extruded semiconducting conductor and insulation shielding materials for electrical wires and cables. The values stated in SI units are to be regarded as standard. No other units of measurement are included in the standard. In many instances, the electrical properties of the shielding material are strongly dependent on processing conditions. For this reason, in this specification, the material is sampled from a cable. Therefore, tests are done on shielded wire in the standard solely to determine the relevant property of the shielding material and not to the test the conductor or completed cable. Next standard is D3005-17 standard specification for low temperature resistant vinyl chloride plastic pressure sensitive electrical insulating tape. This specification covers the properties and requirements for electrical insulating tape consisting of a backing of vinyl chloride plastic coated on one side with a pressure sensitive adhesive for use at low temperatures. Four types are included, providing two thicknesses at two operating temperatures. Selected from standard widths and lengths, the tape shall condone to specified values of the following requirements: break strength, break and static elongation, dielectric breakdown, addition to both steeling and backing, roll and wind, high humidity, insulation resistance, flammability, and behavior during flagging test. Next standard is D3006-10 2017 standard specification for polyethylene plastic pressure sensitive electrical insulating tape. So this specification covers electrical insulating tape consisting of a backing made from polyethylene plastic film coated on one side with a pressure sensitive adhesive. The backing shall be polyethylene suitably compounded to meet the requirements prescribed. The standard widths and lengths of the material are presented. The selection of rows, conditioning, and testing shall meet the requirements prescribed. Next standard is D3032-13 standard test methods for hookup or insulation. test methods detail the standard procedures for testing hookup wire installations, including all components of the insulation system used on single insulated conductors or an assembly of single insulated conductors, such as cable bundle and harness or flat ribbon cable. The insulating material include not only on the primary insulation over the conductor, but also insulating jackets over shielded constructions. The test procedures covered here shall be performed in the conditions or shall determine the properties as follows. Axial stability, longitudinal change, after thermal exposure, bendability cut through, bendability to potting compounds, capacitance, cold band test, concentricity, crush resistance, dielectric breakdown, voltage, dimensions, dry arc tracking, dynamic cut-through, fluid immersion, high temperature shock, insulation continuity prior test, insulation resistance, prior discharge, corona, inception, and extinction voltage. Relative thermal life and temperature index, strip force, surface resistance, tensile properties, vertical flame test, voltage rating at hookup wire, voltage withstand test, and wet arc tracking. Next slide is D3056-14 standard test method for gel time of solventless varnishes. This test method covers the determination of the gel time of solventless varnish mixed with the catalyst if required and exposed to elevated temperature. Gel time is important in determining batch uniformly in some processing characteristics. It is indicative of path life and shelf life. Next standard is D3149-06 2013 standard specification for crosslink polyolefin heat shrinkable tubing for electrical insulation. This TED method is used for determining the effect of exposure to elevated temperatures on the band strength of combination of magnet wire insulations and electrical insulating varnishes. The results are used as guide of the comparison and selection of varnishes and combinations of varnishes and magnet wire insulation for specific applications. Test methods D1932 and D3251 describe additional tests for determining the thermal endurance of insulating varnishes. A comprehensive evaluation of thermal characteristics includes a comparison of the thermal endurance determined in these different ways. Next standard is D3150-11 standard specification for crosslink and non-crosslink polyvinyl chloride heat shrinkable tubing for electrical insulation. This specification applies in two types of flexible crosslink, type 2 and non-crosslink type 1 polyvinyl chloride heat shrinkable tubing for electrical insulating purposes. It is supplied in an expanded form and will shrink to its extruded diameter when heated. Besides dimensional requirements such as inside diameter and wall thickness, the tubing shall also adhere to the following chemical and physical property requirements: restricted shrinkage, longitudinal change, dielectric strength, color and color stability, water absorption, specific gravity, volume resistivity, flammability, heat shock, low temperature flexibility, tensile strength, elongation, heat resistance, resistance to fluids such as hydraulic fluid, GP for fuel, lubricating oils, de-icing fluid, and NaCl solution, copper corrosion, behavior during copper dust, humidity test, and shelf life. Next slide. Next standard is D3288-D3288M 15 standard test methods for magnet wire enamels. These test methods cover testing liquid enamel coatings used to produce film insulated magnet wire. The values stated in either pounds or SI units are to be regarded separately as standard. The test methods appear as follows: density, determined solids, effective solids, flash point, infrared analysis, stock loss, viscosity. Next slide is D33122-4 2013 standard test method for percent reactive monomer in solventless varnishes. The percent of reactive monomer in solventless varnishes will affect this viscosity, the handling, and the processing properties of the cured resin. The percent of reactive monomer will positively affect the degree of hardness and shrinkage, which in turn will affect the physical and electrical properties of the cured resin. Next standard is D3349-17, standard test method for absorption coefficient of ethylene polymer material pigmented with carbon black. The absorption of coefficient of polyolefin polymer pigmented with carbon black is useful to judge the degree and uniformity of dispersion of the pigment. The advocacy of the quantitative level of pigment addition, these factors are used to predict the performance of the polymer material in response to prolonged exposure to ultraviolet light as evidenced by minimal changes in specific properties. This test method was developed to evaluate ethylene polymer materials pigmented with small particle-sized carbon black suitable for UV protection. It is not known how it is not known how accurate and reproducible the test would be with larger 35 nm or greater particle size blocks. Next standard is D3353-10 standard test methods for fibrous insulated magnet wire. These test methods cover the testing of fibrous insulated electrical conductors, commonly referred to as magnet wire, which are not which are used in electrical apparatus. The test methods are intended primarily for evaluation of the electrical insulating materials used. It is intended that these methods be used except where modified by individual specifications for particular applications. This elongation testing method covers the determination of the elongation of fibrous insulated magnets wire that results in a fracture of the conductor. The electrical resisting testing method covers the determination of the electrical resistance of fibrous insulated magnet wire conductors. The fibrous coverage testing covers the determination of the quality of fibrous servings on round magnet wire or bare conductor. The measurement of dimension test methods determine the dimensions of the bare or film insulated conductor and the fibrous insulated magnet wire. The addition and flexibility method covers the evaluation of the flexibility and adherence of varnish fibrous glass and varnish or magnet wire, or unvarnished fibrous polyester glass insulating material on either bare or conductor, or film insulated magnet wire. That the electric breakdown voltage test method covers the determination of the electric breakdown voltage in air of insulation or round rectangular and square wires at commercial power frequencies. Next slide. Next standard is D3376 14 standard test method of sampling and testing pumps to be used in the manufacture electrical insulation. These test methods cover the sampling and testing of cellulosic pulps for use in the manufacture of electrical insulating papers and boards or in the direct application of pulp fibers as insulation to electrical conductors. The significance of any one property test method as set forth herein should be considered with discretion depending on the product made from the pulp. Sections or regions, sampling, and report are integral parts of each of the individual test methods that follow. Each test method is described as being a measure of either a bulk property of the pulp or property of a hand sheet formed from the pulp. Next standard is D3380-14 standard test method for relative permittivity, the electric constant, and dissipation factor of polymer-based microwave circuit substrates. The test method permits the rapid measurement of apparent relative permittivity and loss tangent. Dissipation factor of metal-clad polymer-based circuit substrates in the X band 8 to 12 GHz. And this, that this test method is suitable for testing PT, FE, impregnated glass, cloth, or random-oriented fiber mats. Glass fiber reinforced polystyrene, polyphenylene oxide, irradiated polyethylene, and similar materials having a normal specimen thickness of 1.6 mm. The materials listed is in the preceding sentence have been used in commercial applications at nominal frequency of 9.6 GHz. Next standard is D3382-13 standard test methods for measurement of energy and integrated charge transfer due to partial discharges. Corona using bridge techniques. These test methods are useful in research and quality control for evaluating insulating materials and systems since they provide for the measurement of charge transfer and energy loss due to partial discharges. Pulse measurements of partial discharges indicates the magnitude of individual discharges. However, if there are numerous discharges per cycle, it is occasionally important to know their charge sum, since this sum is related to the total volume of internal gas spaces that are discharging. If it is assumed that the gas cavities are simple capacitances in a series with the capacitances of the solid dielectrics. Internal cavity type discharges are mainly of the pulse spark type with rapid rise times on the pseudo-glow type with long rise times. Depending upon the discharge governing parameters existing within the cavity. If the rise times of the pseudo-glow discharges are too long, they will evade detection by pulse detectors as covered in test method D188. Next standard is D3394. Standard test methods for sampling and testing electrical insulating board. The test method covers the determination of the electric strength of solid electrical insulating materials under simulated lightning impulse conditions. Procedures are given for tests using standard 1.2 by 50 full wave impulses. This test method is intended for use in determining the impulse dielectric strength of insulating materials, either using simple electrodes or functional models. It is not intended for use in impulse testing of apparatus. The test method is similar to IEC publication 243-3. All procedures in this test method are included in IEC 243-3. Differences between this test method and IEC 243-3 are largely editorial. Next slide. Next slide. Next standard is D3395. D3554-07-2013 Standard Specification for Track-Resistant Black Thermoplastic High-Density Polyethylene Insulation for Wire and Cable 75 Celsius operation. This specification covers track resistance, black thermoplastic high-density polyethylene insulation for conducting wires and cables operating continuously at a specified conductor temperature. The insulation is suitable for use for power transmission in overhead space line service that is exposed to sunlight and other atmospheric environments. The prescribed test cannot be performed unless the insulation is formed around a conductor. But, but these are done solely to determine the insulation properties are not to test the conductor or completed table. Each test sample should be subjected to an AC or DC voltage withstand test at voltages that are based on the normal thickness of the insulation should comply with the required values for aging, heat distortion, cold blend, U-bend discharge, track resistance, tensile strength, elongation at rupture, environmental cracking, and surface resistivity. Next standard is D3555-07-2013 standard specification for track resistant black cross-linked polyethylene insulation for wire and cable 90 degrees Celsius operation. This specification covers track-resistant black cross-linked polyethylene insulation for conducting wires and cables operating continuously at a specified conductor temperature. The insulation is suitable for use for power transmission in overhead space line service that is exposed to sunlight and other atmospheric environments. The prescribed test cannot be performed unless the insulation is formed around the conductor. So, these are done solely to determine the properties on the nominal thickness of the insulation and should comply with the required age, jing heat distortion, cold blend, U-bend discharge, track resistance, tensile strength, and elongation of rupture track resistance, and surface resistivity. Next standard is D3636-13 AE1 standard practice for sampling and judging quality of solid electrical insulating materials. This practice covers procedures for obtaining data on the quality of solid electrical insulating materials and for judging whether the materials meet the requirements specified. This practice, however, is not intended to define internal quality control procedures of the producer. Rather, it is designed to determine the acceptability of all or some portion of a quantity of electrical insulating materials available for inspection by the other user of the material. In addition, this practice is intended for use in conjunction with existing material specifications including property characteristic limits, acceptable quality level, standard test methods, and sampling instructions. Data shall be obtained by taking blood samples randomly. Sampling plans are available in single, double, and multiple types. Acceptable quality levels for each critical, major, and minor property as well as inspection levels shall conform to the requirement specified. Acceptance of lot quality shall be determined on the comparison of test results and other information obtained using the sampling plans with the requirements set forth in the material specification, non-conformity, and on whether the lot meets up the requirements specified. And next standard is D3874-13 standard test method for ignition of materials by hot wire sources. During operation of electric equipment, including wires, resistors, and other conductors, it is possible for overheating to occur under certain condition of operation or when malfunction occur. When this happens, a possible result is ignition of the insulation material. This test method assesses the relative resistance of electrical insulating materials to ignition by the effect of hot wire sources. This test method determines the average time in seconds required for material specimens to ignite under the specified conditions of test. This method is suitable to characterize materials subject to the appropriate limitations of unexpected precision of plus and minus 15% to categorize materials. Next, standard is going to be reported by my groupmate James Montero.
Hello, mic check. Hello? Rinig ba ako? So, the next standard is ASTMD 3955-13. Rinig ba ako, guys? Mic check. ASTMD 3955-13. Standard specification for electrical insulating varnishes. This specification covers the test and values for electrical insulating varnishes as supplied, which are suitable for the impregnation and treatment of electrical coils and windings applied by deep process. So the next is ASTMD 4063-99-2016, which is the standard specification for press board for electrical insulating purposes. So in this specification, it covers press board for electrical insulating purposes and manufactured from craft cotton or craft and cotton pulps. This board is intended for dielectric or structural purposes in transformers and other electrical apparatus. And in 1.2, electrical insulating boards are most commonly referred to and will be referred to herein as press board. Other terms used to press boards include transformer board, Fowler board, and press pan. And in 1.3, this specification covers press board having a nominal thickness of 0.030 to 0.315 inches or 0.8 to 0.828 millimeter. For thinner materials refers to specification D1305. 1.4. The maximum thickness available will differ with the type and the manufacturer. The maximum sheet size will differ with the thickness, type, and manufacturer. So, and in 1.5, that have been in 1.5, press board shall normally be applied wet without fasting, unless specified by the purchaser. This specification does not include press board. check, 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 check. Hindi ba ako rinig? Mic check. Hello, hello, hello. Check. Anong standard yun na? So, s- balik tayo sa 1.3. This specification covers pressboard having a nominal thickness of... So, tapos na ako dito. Dito na ako sa next standard, which is ASTM D4243-16. Standard test method for measurement. Wait lang. Standard. This method, standard test method for measurement of average viscometric degree of polymerization of new and aged electrical papers and boards. So in 1.1, this test methods describes a standard procedure for determining the average viscometric degree of polymerization of new age electrical papers. The determination is made by measuring the intrinsic viscosity of a solution of the paper in an appropriate solvent. In 1.2, the degree of polymerization or the degree of condensation of a particular cellulose molecule is the number of anhydroglucose monomers C6H1005 in the cellulose molecule within a sample of paper. Not all the cellulose molecules have the same degree of polymerization, so that the mean value measured by viscometric methods is not necessarily the same as that which are obtained by other methods. In 1.3, this standard may involve hazardous materials, operations, and equipment. This standard does not support to address all of the safety concerns, if any, associated with its use. It is the responsibility of the user of this standard to establish appropriate safety and health practices and to associated with its use and responsibility of the users appropriate safety and healthy practices and to determine the applicability of regulatory limitations prior to use. More information is in section 9. So the next standard is ASTM D4245-08 08, which is the standard specification for ozone resistant thermoplastic elastomer insulation for wire and cable. 90 degrees Celsius dry and 75 degrees Celsius when wet operation. So, in, in this specification, covers an ozone-resistant insulating compound for electrical wire and cables 14 AWG and larger. This compound consists substantially of a thermoplastic elastomer. This type of insulation is suitable for continuous operation and conductor temperatures not exceeding 90 degrees Celsius in dry locations and 75 degrees Celsius in wet locations. Operating voltages are not to exceed 2000 voltage. The minimum installation temperature is negative 40 degrees. So the values stated in each pound units are to be regarded as standard. The values given in parentheses are mathematically conversions to SI units that are provided for the information only and not considered standard. In many instances, the insulation material cannot be tested unless it has been formed around the conductor or cable. Therefore, tests are done on insulated wire or cable in this document solely to determine the relevant property of the insulation material and not to test the conductor or completed cable. So in next standard, the ASTM D4246-14 which is the standard specification for ozone-resistant thermoplastic elastomer insulation for wire and cable in 90-degree operation. So, in this specification, it covers an ozone-resistant insulating compound for electrical wire and cables, and 14 AWG and layer. So, this compound consists substantially of a thermoplastic elastomer. And in 1.2, this type of insulation is considered suitable for continuous operation and conductor temperatures not exceeding 90 degrees Celsius in dry locations. Operating voltages are not to exceed 2000 voltage. The minimum installation temperature is 40 degrees Celsius. So, in many instances, the insulation material cannot be tested unless it has been formed around the conductor or cable. Therefore, tests are done on insulated wire or cable in this specification solely to determine the relevant property of the insulation material and not to test the conductor or completed cable. In 1.4, whenever two sets of values are presented in different units, the values in the first set are to be regarded as standard. The values given in parentheses are mathematically conversions that are provided for information only and are not considered standard. So in 1.5, the international standard was developed in accordance with internationally recognized principles on standardization established in the Decision on Principles for the Development of International Standards, Guides, and Recommendations issued by the World Trade Organization Technical Barriers to Trade or TBT Committee. So in the next standards, the ASTM for 313-17, which is the standard specification for general purpose, heavy duty, and extra heavy duty cross-linked chlorinated polyethylene or CM jackets for wire and cable. So in 1.1, this specification covers cross-linked chlorinated polyethylene or CM compounds sustainable for use as outer covering or jackets on electrical cables for general purposes, heavy duty, and extra heavy duty service. In 1.2, these jackets materials are not recommended for use on cables which are to be installed at a temperature less than negative 25 degrees. So, in 1.3, the values stated in inch-pound units are to be regarded as standard. Then the values given in parentheses are mathematically conversion to SI units that are provided for information only and are not considered as standard. So in 1.4, this international standard was developed in accordance with internationally recognized principle on standardization established in the decision on principles for the development of international standards, guides, and recommendations issued by the World Trade Organization, Technical Barriers to Trade, or TBT Committee. This specification covers cross-linked chlorinated polyethylene compounds intended for use as jacket materials or outer coverings on electrical wires and cables for general purpose, heavy duty, and extra heavy duty service. The materials under this specification, however, are not recommended for applications with very low temperature service requirement. Physical tests shall be performed and shall conform to the physical property requirements specified such as tensile strength, tensile stress, and elongation. Elongation at rupture and tension set per service requirement. Additional tests for sunlight and weather resistant shall be performed as well and shall conform to. So the next standard is the ASTM D4325-13, which is the standard test methods for non-metallic, semiconducting, and electrically insulating rubber tapes. So the significance and use is in 5.1, the physical and electrical properties, including break strength, elongation, dielectric strength, dissipation factor, permittivity, fusion, etc., will vary with temperature and moisture content. Control the temperature and moisture content of the sample for these test methods to yield consistent and reproducible result. So the scope naman in 1.1, these test methods covered the methods and procedures for testing electrically insulating and semi-nonmetallic conducting rubber tapes designed for splicing, terminating, and sheet repair of electrical wire and cable. And electrical wire and cable. And 1.2, the test methods appear in the following section. So 1.3, the values. So in 1.3, the values stated in SI units are to be regarded as standard. The values given in parentheses are mathematically conversions to inch-pound units that are provided for information only and are not considered standard. So, note 1, there is no IAC equivalent to these methods. Number 1.4, unless otherwise stated, measurements are made on tapes from which the removable separator has been removed. In 1.5, this standard does not support to address all of the safety concerns, if any, associated with its use. It is the responsibility of the user of this standard to establish appropriate safety and health practices and determine the applicability of regulatory limitations prior to use for a specific precaution statement. So this is a per test response standard. So we have a table here na ito yung sa test methods appear in the following section. So in reference document sa section 2, sa conditioning nasa section 5 to 6, dielectric strength nasa 35 to 40, dimension 11 to 16, dissipation factor 22 to 26, elongation 17 to 21, heat exposure 46 to 49, fusion is 7 to 10, ozone resistant 41 to 45, permittivity 22 to 26. Sample requirements is 4. Tensile strength is in section 17 to 21. Volume resistivity is in section 27 to 34. Ultraviolet and weather resistance is in section 50 to 54. So the next is standard ASTM D4363-17, which is the standard specification for thermoplastic chlorinated polyethylene CM or CM jacket for wire and cable. In the abstract, this specification covers thermoplastic chlorinated polyethylene or CM compounds suitable for use as an outer covering or jacket on electrical cables. Thermoplastic jackets shall conform to the requirements for physical properties specified. The sunlight and weather resistance of the jackets shall be tested to meet the requirements specified. Scope: this specification covers thermoplastic chlorinated polyethylene or CM compounds suitable for use as an outer covering or jacket on electrical cables. In 1.2, used these jacket materials are suitable for use on cables which will be installed at temperatures above negative 35 degrees Celsius at 35 degrees Celsius. And in 1.3, the values stated in inch-pound units are regarded as standard. The values given in parentheses are mathematical conversions to SI units that are the values stated in inch-pound units are regarded I the values given in parentheses are mathematically conversions to SI units that are provided for information only and are not considered standard. In 1.4 in 1.4 This international standard was developed in accordance with internationally recognized principles on standardization established in the Decision on Principle for the Development of International Standards, guides and recommendations issued by the World Trade Organization, technical barriers to trade TBT committee. And the next standard, the ASTM D4388-13 or the standard specification for nonmetallic, semiconducting, and electrically insulating rubber tapes. In the abstract, this specification covers nonmetallic semiconducting and electrically insulating rubber tapes designed for the splicing and repair of electrical wire and cables operating at specified phase-to-phase voltages. The tapes, which are classified into five types, the type 1, 2, 3, 4, and 5 shall conform to physical property requirements such as tensile strength, elongation at break, dielectric strength, dissipation factor, permittivity, volume resistivity, behavior during fusion tests, ozone resistant, heat exposure, and UV resistant. In the scope, in 1.1, this specification covers non-metallic semiconducting and electrical insulating tapes designed for the splicing and repair of electrical wire and cables operating at voltage up to 325 kV phase-to-phase or kilovolt. 1.2. The SI values are standard. The values stated in inch-pound units given in parentheses are for information purposes only. The next standard, the ASTM D4470-97 of 2004, which is standard test method for static electrification, though the significance and use is in whenever two dissimilar materials are contacted and separated, Excess electrostatic charge or triboelectric charge will be found on this material if at least one of the materials is a good insulator. This excess charge gives rise to electric fields which can exert force on other objects. If these fields exceed the breakdown strength of the surrounding gas, a disruptive discharge or spark may occur. The heat from this discharge may ignite explosive atmospheres. The light may fog photosynthesis materials, and the current flowing in a static discharge may cause catastrophic failure of solid-state devices. Electric forces may be used beneficially as in electrostatic copying, spray painting, and beneficiation of ores. They may be detrimental as when they attract dirt to a surface or when they cause sheets to stick together. Since most plastic materials is in use today have very good insulating qualities, it is difficult to avoid generation of static electricity since it depends on many parameters. It is difficult to generate static electricity reliable by reproducib- repro- reproducibly. Those in the scope, so in 1.1, this test method covers the generation of electrostatic charge, the measurement of this charge and its associated electric field, and the test conditions which must be controlled in order to obtain reprodu- reproducible results. This test method is applicable to both solids and liquids. This test method is not applicable to gases, since a transfer of gas with no solid impurities and it does not generate an electrostatic charge. This test method also does not cover the beneficial uses of static electrification, its associated problems or hazards, or the elimination or reduction of unwanted electrostatic charge. In 1.2, the values stated in SI units are to be regarded as the standard. This standard does not purport to address all of the safety concerns, if any, associated with its use. It is responsibility of the user of this standard to establish appropriate safety and health practices and determine the applicability of regulatory limitations prior to use. So the next standard naman, the ASTM D4496-13, which is the standard test method for DC resistance or conductance of moderately conductive materials. Significance and use. The 5.1. This test method is useful for the comparison of materials as a quality control test and for specification purposes. In 5.2, this test method is useful in the selection and use of materials in wires, cables, bushings, high voltage rotating machinery, and other electrical apparatus in which shielding or the distribution of voltage stress is of value. Excuse me. The 5.3, commercially available moderately conductive materials frequently are comprised of both conductive and resistive components, that is, cellulose fibers with colloidal, colloidal carbon black particles attached to the portions of the surfaces of those fibers, or discrete conductive particles adhered to the surfaces of electrical insulating polymers. Such commercially available materials are often manufactured in a manner that results in anistos, anisotropy, anisotropy of electrical conduction. Hence, the significance of tests using the test methods depends upon the orientation of the specimen tested to the direction of the electric field and the relationship between this orientation and the orientation of the material in the electrical apparatus which uses these materials. So in the scope naman in 1.1, this test method covers the determination of electrical resistance and electrical resistivity of materials that are generally categorized as moderately conductive and are neither good electrical insulators nor good conductors. And in 1.2, this test methods applies to the materials that exhibit volume resistivity in the range of 100 to 107 ohms centimeter or surface resistivity in the range of 103 to 107 ohms per square. In 1.3, this test method is designed for measurements at standard conditions of 23 degrees Celsius and 50-degree relative humidity, but its principles of operation can be applied to specimens measured at lower or higher temperatures and relative humidities. Oh, and in 1.4, this standard does not purport to address all of the safety concerns, if any, associated with its use. It is the responsibility of the user of the standard to establish appropriate safety and health practices and determine the applicability of regulatory limitations prior to use. So in ASTM, next standard na to, ASTM D4514-12 standard specification for friction tape withdrawn on 2020. The abstract consists con- the abstract content is this specification covers friction tapes that are commonly used for protecting and binding in place insulation applied to joints of electrical wires and cables and for other mechanical purposes. The tape shall consist of a woven fabric sheeting impregnated with a frictioning compound, an adhesive insulating compound, cut into rolls of narrow width and wound on a core. Friction tapes shall meet the prescribed requirements such as adhesion, edge adhesion, breaking strength, breaking down voltage, parallelism, and tackiness. The specified dimensional requirements includes nominal width, thickness, and length. The aging and storage requirements, as well as the test methods to determine conformance to the prescribed requirements are given. So in the scope, in 1.1, this specification covers friction tapes that are commonly used for protecting and binding in place insulation applied to joints of electrical wires and cables and for other mechanical purposes. And in 1.2, the values stated in inch pound units are to be regarded as the standard. The values in parentheses are for information only. So the next standard, which is the ASTM D4566-14, which is the standard test methods for electrical performance, properties of insulation and jackets for telecommunications, wires and cables. Wires and cables. For the testing, so for wires and cables. So the significance and use is in 5.1, electrical test properly interpreted provide information with regard to the electrical properties of the insulation. The electrical test values give an indication as to how the insulation will perform under conditions similar to those observed in the test. Electrical tests provide data for research and development, engineering design, quality control, and acceptance or rejection under specifications. And in the scope, 1.1, these test methods cover procedures for electrical testing of the thermoplastic insulations and jackets used on telecommunications, wire and cable, and for the testing of electrical characteristics of completed products. To determine the procedure to be used on the particular insulation or jacket compound, or on the end product, reference should be made to the specification for the product. The test methods appear in the following section of this standard. In 1.3, the values stated in inch pound units are to be regarded as standard. The values given in parentheses are mathematically conversions to SI units that are provided for information only and are not considered standard. This standard does not purport to address all of the safety concerns, if any, associated with its use. It is the responsibility of the user of this standard to establish appropriate safety and health practices and determine the applicability of regulatory limitations prior to use. So this is the test methods and their sections. For electrical tests of insulations in process, the section is on 4 to 8. For DC proof tests, it's in section 8, and insulation defect or fault rate is in 7. Spark test is in 6. Electrical tests of completed wires and cables is in 9 to 51. Annu- Attenuation is in 24, and the attenuation effects due to aging is in section 31, and the attenuation effect due to elevated temperature is in 29. Attenuation effects due to humidity is in 30, and the attenuation to crosstalk ratio par end or ACR-F is on 28, and the capacitance deviation is on 26. Capacitance difference is on 19. The capacitance deviation is on 19 pala. So the capacitance difference is on 20. The capacitance unbalance pair to ground or CUPG is on 22, section 22, and the capacitance unbalance pair to pair, which is CUPP, is on section 21. Capacitance unbalance or pair to support wire is on section 23. Characteristic impedance method 1, propagating constant and capacitance is on section 47. Characteristic impedance method 2, single-ended measurements in section 48. Characteristic impedance method 3, least square function fit is on section 49. Coaxial capacitance to water is on section 17. Conductor continuity is on section 11. And conductor resistance or CR is on section 13. Conductor resistance unbalance or CRU of pairs is on section 15. Section 12 for continuity of other metallic elements. Section 35 for crosses test, continuity between wires of different pairs. And then section 27 for crosstalk loss far end. For crosstalk loss near end naman is in section 25. And on section 40, the, you will find the DC proof test core 2 internal shields, which is screen, and DC proof test core to shield naman is on section 38. DC proof test core to support fire, section 39. DC proof test internal shield screen to shield, section 41. DC proof test other required isolation, section 42. DC proof test wire to wire on section 37. Fault rate test air core only, section 32. Installation resistance or IR on section 32. So the next standard, which is ASTM D4568-13 of 2020, which is the standard test methods for evaluating compatibility between cable filling and flooding compounds and folio, polyolefin wire and cable materials. Significance and use. 4.1. Cable filling and flooding compounds are normally semi-solid at room temperature and fluid in varying degrees and elevated temperatures. They are normally applied in a liquid state and at an elevated temperature during wire and cable manufacturing. The completed finished wire or cable is exposed to various ambient conditions during its useful life. If not carefully selected, components of filling or flooding compounds have the potential to degrade the materials they contact, short term or long term. The following methods are intended to minimize the chances of such problem occurring. So on method 4.1, 4.2.1, delamination of coated metal shields or screen in completed wire and cable. Delamination is primarily a function of the test temperature and the type of laminant used. So test results are unlikely to vary significantly between filling or flooding compounds of a common family. For example, the petroleum-based filling or flooding compounds. In section 4.2.2, degradation of physical properties of insulation, jackets, core covering, and etc. Likely manifestations of deg- degradation of plastic material include embrittlement of some materials and excessive softening of other materials. So in section 4.3, since the magnitude of any given effect will vary, some test procedures will be more critical than others. It is not therefore intended that every listed procedure be performed with every compatibility study. Perform procedures to the extent required by the product specifications or as agreed upon between the producer and the purchaser. So in the scope of 1.1, these test methods evaluate the compatibility between cable filling or cable flooding compounds or both and polyolefin materials used in the manufacture of wire and cable that are usually in intimate contact with the filler or floodant, or both. So in 1.2, these test methods are useful to ensure compatibility and to vary that new formulation of filling or flooding compounds will have no deleterious deleterious effect upon the other. Poly Polyolefin materials being used or conversely use these methods to ensure that other polyolefin wire and cable materials are evaluated for possible use, not degraded by contact with fillers or floodants already in use. So in 1.3, whenever two sets of values are presented in different units, the values in the first set are to be regarded as standard. The values given in parentheses are mathematically conversions that are provided for information only and not considered standard. This standard does not purport to address all of the safety concerns, if any, associated with its issue. It is the responsibility for the user of the standard to establish appropriate safety, health, and environmental practices and determine the applicability of regulatory limitations prior to use. In 1.5, this international standard was developed in accordance with internationally recognized principles on standardization established in this decision on principle for the development of international standard guides and recommendations issued by the World Trade Organization Technical Barriers to Trade or TBT Committee. And in next standard, the ASTM D4730-13, which is the standard specification for flooding compounds for telecommunications wire and cable. The abstract contains this specification covers a variety of compounds used for flooding the shields and armors of telecommunications wires and cables, both electrical and fiber optic, for the purpose of preventing water and other undesirable fluids from entering or migrating along or through the cable sheet. The material may be of any chemical composition suitable for the intended purpose and should meet the requirements specified. The flooding compound shall display adhesive properties to provide adhesion between metallic sheet elements and other outer jacket materials of wire and cable. All flooding compounds manufactured in conformance to this specification shall meet the following requirements: homogeneity and foreign material. Scope. In 1.1, this specification covers a variety of compounds used for flooding the shields and armors of telecommunications wires and cables, both electrical and fiber optic, for the purpose of preventing water and other undesirable fluids from entering or migrating along through the cable sheet. For related standards, see specification on standard D-port 731 and D-port 732. So the next standard will be reported by my group mates Malparta Marvin. Pre, nakamute ka ata pre. Hindi ka rinig. Wait lang. Pasok uli ako. Pre.
Okay na?
Oh, rinig ka na. Wait lang ah.
G, narinig ako?
Oo, rinig ka na. Kita mo yung slide?
Oo, gege pa rin may copy ako. Isang cellphone.
Okay na, okay na.
Goods, goods.
Oo.
Yeah. Good morning, everyone. This is reporter Marvin Malparta. This is a continuation of American's standard testing material. The first standard is B4731-13 in 2020. Standard specification for the hot application filing compounds from the telecommunication wire and cable. This is specification cover a vari- variety of the petroleum based on the other compounds use the filing air, space, and telecommunication wires and cables, both of electrical fiber optic for the purpose of preventing water and other un- undesirable fluid from the entering or migrating through the cable structure. The two basic types of filing compounds are specified. Type 1, which is general purpose filing compound, include the material to be used for filing cables that are not required for function under electrical stress, and the type 2, which is electrical type filing the compounds and include materials having a prescribed electrical properties, and use the filing wires and cables that are required for function fully or partially under electrical stress. Filing compound furnished um, furnishes shall in inhibited to corrosion any metallic wire and cable elements with which it comes in contact, while serving the radial and longitudinal barrier for the moisture transmission. Contact the filing compound with the cable component shall be not degrade- degradation of performance of the cable. The filing compound shall display adhesive properties of provide adhesion between metallic sheet elements and outer jacket materials of the cable. The following properties filing compound manufacturer shall be determined: homogeneity, color or capacity, color stability, foreign materials, and other properties that includes volatility, thermal oxidative stability, and corrosion prevention. The scope of this standard specification for application filing compounds, telecommunication wires, and cables are 1.1. This is specification cover variety of petroleum-based the other compound used for filing in air, space, telecommunication wires and cables, but electrical and fiber optic for the purpose of prevent water and undesirable fluids from the entering migrating into cable structure from the related standard specification D4730 and D4730. In 1.2, a hot application compound in material requires melting to other applied as liquid. Its melting point effect in performance in the finished cable product. And 1.2, 1.3, the values state that SI unit are the are to be sorry regarded the standard. The value given a parenthesis after SI units are provided information only and are not considered standard. In 1.4, this international standard was developed accordance That's with the international recog- recognized principle of standardization established between decision on principle for the developing international standard guides with recommendation issued by World Trade Organization technical barriers and to trade B a TBT community. For the next slide, please. In the another slide is another standard is 47 B4732-13 standard specification for cooling application filing compounds for tech, telecommunication wiring cables. This specification covers types of cool application compound used for filing airspace telecommunication wires and cables, both of electrical and fiber optic are are optic for the purpose of preventing water other undesirable fluids entering a migrating through the cable structure. Type 1 are general purpose filing compounds including the materials to be used for filing cables that are not required to function under electrical stress. For example, all, all dielectric fiber optic cable, including filing compounds for fiber optical loose buffer tube, while type 2 are the electrical type filing compounds, including materials having described electrical properties and used for filing wires and cables that require to function fully or partially under electrical stress, including hybrid fiber optical cable to chemical composition is not specified. Specified. The filing compound shall be, however, tested to conform accordingly to the following physical, and temperature characteristics as agreed upon between procedure and purchaser. The raw material state evaporation loss, water resistance, homogeneity, color and optical colors, stability, foreign materials, vol- volat- volatility, terminal oxidative stability, bond penetration, 4 point, drop melting point, viscosity, collagen point, drop point, cable, deep out temperature, in cold bind, low temperature flexibility. The scope for this is 1.1. This is specification called variety, variety, variety. The compound used for filing the air, space, telecommunication, wires and cable, both electrical and fiber optic, for purpose of prevent water and other undesirable fluids from entering migrating through the cable structure. For related standards is specification B4730 and B4731. In 1.2, a cooling application compound is a metal that has sufficiently low viscosity that it does not require heating. In 1.3, the values stayed in SI units are to be regarded to standard. The value given in parentheses are a mathematical conversion in inches pound. Units that are provided information only are not considered standard. To in the next slide, please. Okay, the next slide are standard D4733-17 standard test method for solventless electrical installation varnishes. The significance and use. In 4.1, the test method refers to the test method useful for control purpose during the manufacture and used for solventless varnishes. Scope. In 1.1, those test method covers solventless varnishes used primarily as electrical, mechanical, environmental protection for electrical equipment. In 1.2, those test methods are used for solvents and varnishes that are applied by dipping at atmospheric pressure condition under the vacuum under certain pressure. Certain pressures, spraying or brushing for the purpose of impregnating impregnate, impregnating or sealing the electrical equipment. The following test methods would be used. For the section 7 is density, section 8 is flash point, and section 9 is gel time, section 10 is mono, monomer content, sorry, and section 11 is rheological properties non-Newtonian, non-Newtonian, and section 12 is rational viscosity. In section 13 is bond strength. In section 14 is cooling thickness. Section 15 is the electric strength. Section 16, the electric strength using metal panels. And section 17 is per- permet, ano? Permittivity and dissipation, permittivity and disposition factors. And section 18 is build. In 1.3, in 1.3, the values state the inch pound unit for the regarded to standard values. Percent parentheses are information only. 1.4, this standard does not purport to address all of safety concern, if any, associated with its use. It is the responsibility of the user of this standard establishment of appropriate safety, health, and environmental practices that determine applicability, regulatory elimination period prior to use, specific hazard statement given in 83-15.5.1 and 15.5.2. In 1.5, this is international standard development for the internationally recognized principle of standardization, establishing decision on the principle of the developed international standard guide for recommendations issued by World Trade Organization and technical barriers to trade (TBT) committee. Next slide, please. Wala. In standard D4872-14 in 2020, standard test method for dielectric testing wire and cable filing compounds significance in use. 5.1 Dissip- Dissipation factor, permittivity, and DC volume resistivity are properties of the communication cable fi- filers and filler components that are controlled in the other that the cable electrical performance falls within the design limits. Relative, relatively small amounts of contaminants such as polar compounds, water, or salt degree that cable's electrical properties limits of dielectric properties of the cable filing component are usually specified specified by the cable manufacturer by industry standard to group scope. In 1.1, this test method covers determination of dissipation factor, permittivity, dielectric constant, and AC volume resistivity of wire and cable filing compounds. And related materials are solid from room temperature but cable being melted to elevate temperature. In 1.2, whenever two seats are valued and presented in different units, the value is the first seat is standard, while those in parentheses are for information only. Appropriate safety, health, and environmental practices determine applicability or regulatory elimination prior to use. Specific specific ha- hazard statement given in the section 7. In 1.4, this international standard was developed according with the inter, inter, internationally recognized principle standardization established by decision of principle for the development of international standard guides, recommendation issued by World Trade Organization, technical bodies for the trade committee. The next standard is B4880-14 standard test method for saltwater for roughness insulating varnish for enamel magnet wire. In 4.1, this test method is useful to determine the performance varnish or enameled magnet wires subject to the specific sodium chloride solution. It is useful for evaluating the resistance of varnish magnet where the diluted sodium chloride solution under applied voltage scope. In 1.1, this test method covers electrical performance and specified water solution in insulating varnish applied over a name-lead magnet wire. In 1.2, value state SI units to be regarded as standard. The values given the parentheses, the mathematical conversation inches font units that are provided information only are not considered standard. In 1.3, this standard does not purport to address to all safety concerned and associated with the responsibility user based standard establish appropriate safety and health practices determine applicability, reproducibility, regulatory elimination prior to use specific perception statement given the section 6. The next page, please. The next standard is D4881-05 in 2017 standard test method for the terminal endurance of varnish, fibrous, or film-worn magnet wire. Significant in use in 4.1 individual varnishes behave differently when applied to the same fibrous or film-worn magnet wire exposed to elephant temperature. Likewise, a varnish does not always behave the same when applied to different types of fibrous or film-worn magnet wires in figure number 1 for forming wire. In 1.1, this testing method covers determination to terminal endurance of the rectangular and square fibers or, or film warp warp magnet wire coated with the installation varnish. In 1.2, values given in SI unit the standard. The value given is parentheses are information only. In 1.3, this is standard does not purport to address all of the safety concerns. If the associated with the use is a responsibility of user of this per- perpendicular perco- precautionary statement is given in section 5. In 1.4, this is international standard must develop according to WIT, internationally recognized principle on standardization established in the decision of principle of the developing international standard guide and recommendation issued by the World Organization technical barriers to the trade. Next, the next standard is D4882-17 standard test method for bond strand electrical insulation varnish by the twist coil test. In 5.1, varnish obtained the flexural test provides information in regard to bond strength in particular varnish in combination with a particular type of magnet wire when measured under the conditions described in this test method. In 1.1, this is a test method covers the determination of the bond strength of the electrical insulating varnish when applied the twist coil in film insulated magnet wire. The use for particular type of film insulated wire will show the value that combination of film coating and varnish. The value stayed in inch-pound units for the standard. The value given parentheses for information only. This is a standard that address safety concern associate the responsibility for the standard establishing appropriate safety, health, environmental practices, and determine the applicability regulatory elimination prior to use. Specific precautionary statement is given for Section 7. In this international standard was developed according to international recognized principle of standardization established by decision principle for development international standard guide for recommendation issued by World Organization Technical Barriers to Trade and Committee. The next standard is the 4935-18 standard test method measuring electromagnetic shielding effectiveness of planar materials. In 4.1, this test method applied the measurement of SE of planar materials under the normal incidence far field plan wave condition E and H tan- tangential to the surface of the materials. 4.2 Uncertainly, the measured SI value function of material is matched throughout the transmission line path. Dynamic range of measurement system and the accuracy of the ancillary equipment in uncertainty analysis is a given approx appendix X1 to illustrate the probability of uncertainty achieved by an experienced operator using the good equipment deviation from the procedure in the test method while increase the uncertainty. Certainly, in 4.3, approximate near field values of SE can be calculated for both E or E source by using measured value for far field SE. A program can be generated from the source code in Appendix X2 that is suitable for use for personal computer. The 4.4 the test method measurement is equals to reflection absorption. The reflected absorbed power measurement accomplished by additional of a collaborate bidirectional coupler to the input of folder. The next page, this test method provides to measurement electromagnetic or EM shielding effectiveness SE of planar material for a a plane a far field ME wave. From the measured data, near fields CE value the calculated magnetic each short source for the electrically thin specimen 1 and 2 electric E field CE values are also able to calculate from the same far field data, but their validity and applicability have not been established. 1.2 measurement method is a valid for frequency range of 30 MHz to 1.5 GHz. Then limits are not exact but are based on decreasing the replacement current at higher frequency for the size specimen folder described as the test method. Selected a number described frequency within range for electrically thin isotropic materials that frequency independent electrical properties, conductivity, permittivity, and permeability. Measurement will be possible need to only few frequency is as the far field SE. Values will independent of frequency if the material is not electrically thin. If any parameters varied with one vary with the frequency make measurement at several frequencies within a band of interest. In 1.3, this method is not applicable to cables or connectors. In 1.4 units, the value stayed SI units are the regulated standard. No other units or measurement included in standards. In 1.5, this standard does purport to address all safety concerns it associated with the use. It is a responsibility of user standard established workplace safety tulad ng sinabi kanina, ganun pa rin. In 1.6, this international standard was developed according to internationally recognized principles. Standardization established a decision principle for development of international standard guides and recommendation issued by World Trade Organization technical bodies to the Trade Committee. The next standard is D 4967-99 in 2013, standard guide for selecting materials to be used for insulation, jacketing, and strength components of fiber optical cables. The 1.1, this guide is intended to provide a list of materials commonly used for components that provide insulation, jacketing, and strength of fiber optical cables, where those materials covered by American Standard Testing Material Standard appropriate reference made due to the changing technology. Not all materials being used were necessarily listed here. In 1.2, this guide does not include the material used for com- components of optically purpose optical fiber coating or external metallic armoring such as barrier and rodents. Rodents. Next page. The next is standard D4967 by I-99 2013 standard guide for selecting materials used for installation jacketing strength components of fiber optical cables. The 1.1 is guide for intended provide to list material commonly used for components that provide insulation, jacketing strength in fiber cables, where those materials covered by American standard testing material. An appropriate preference is made due to changing technology that a material being used are necessarily listed for here. In 1.2, this guide does not include the material used for components of optical purposes, optical fiber and coating, or external metallic armoring such as a for rodent, barrier to rodents. And the next standard is D5032-11 standard practice for maintaining constant relative humidity by means of aqueous glycerin solution. Control relative humidity environments important for the conditioning material for shell life study for the investigating the change of physical and the electric prote- properties after exposure. The use for aqueous glycerin solution consider a possibility constitutional of the material corrosion of electrode system which would be more likely result from the saturated salt or acid water solution. Application materials specification should be sorry, state for exposure condition including time, temperature, and relative humidity. That material should be subject to the before sub subject to before subsequent testing. Technical conditions are given to practice in D618 or D6054 scope. I in 1.1 this is practice describe the method of obtaining constant relative humidity range from 30 to 98%, temperature ranging from 80 to 70 Celsius, so relatively small contains by means means of the aqueous glycerin solution. 1.2, this practice applicable from closed system environmental condition containers. And 1.3, this practice not recommended from the generated continuous flowing stream the constant humidity unless precautionary certain criteria to follow that ensure the source stability. In 1.4, this standard does not purport stand address for the safety concern if that associate with the with its use. It is the responsibility of user standard establishment appropriate safety and health practices and determine the applicability for regulatory elimination prior to use. The next standard D5109-12 standard testing method covered clad thermal settings eliminates for printed wiring boards withdrawn in 2020. The abstract test method established the standard procedure to testing copper clad laminates procedure from the fiber reinforced thermosetting pol- polymer pol- polymeric materials intended for fabrication of printed wiring cords. The properties of those test methods shall be examined for the following: the directional breakdown voltage parallel to laminations, dimensional instability, dissipation factor, flammability rating, plot-wise flexural strength at more at room the level temperature, behavior during the blast Biles a blister test, flow resistance, surface and volume resistivity, thickness, warp, twist, and water absorption. In 1.1, those test methods cover a procedure for testing copper clad laminates to see produced from fiber reinforced thermosetting polymer material intended for the fabrication printed wiring boards. 1.2 Reduce procedures appear in the following section. In section 2 is reference documents. In section 4 is conditioning. Section 13 is dielectric breakdown voltage parallel lamination. Section 19 dimensional instability. Section 614 is dece- deception factor. Section 16 is flammability rating test. Section 15 is flux, fluctual strength, flat-wise relevant temperature. Section 17 of oven blaster test. Section 10, Section 10 field strength test 11 temperature. Section 9 is field strength test at room temperature. And Section 14 is permittivity. Section 20 pinholes copper surface. Section 5 is purity of copper. Section 21 is scratches of copper surface. Section 8 is solder float test. Section 7 solvent resistant. Section 11 surface resistant. Section 11 volume resistant. resistivity, Section 3, terminology, Section 18, thickness and thickness variation, and Section 6, wrap or twist, and Section 12, water, water absorption. Next slide, please. In 1.3 metric units or preferred units for those test method, inch pound units were shown. I presented the information only 1.2. This standard does not purport address all of the safety concerns. If you are conceived with use, it is a responsibility of user of this standard establishment to appropriate safety health practices and determine applicability regulatory eliminator prior to use. Another standards D5213-12 standards specification for polymeric resin film for electrical insulation, the electric application. This, this specification establishes the requirements for the material, dimension, and tolerance and property values of polymeric resin, resin films in sheet of strip form for use electrical insulation, dielectric application. Type 1 is flexible unsupported films and general purpose welfare. Type 2 is a heat sealable coated on one. Grade 1 is both grade to side material covered here in A, poly, N by N minus B oxidipen, oxidiphenylene, pyrometamide, polyoxidilethylene, bipyl tricarbon, carboxylamide, um, phenylene, diphyltetracarboxylamide, FEP, fluorocarbon, polyethylene terephthalate, polyethylene nap- naphthalate, and other polyether polyethermide individual material plus will shall be tested confirmed accordingly following properties value tensile strength elongation shrinkage moisture absorption dielectric strength volume sensitivity permittivity and dispersion factor. In 1.1, this specification cover requirements material dimension and tolerance and property values of fuels in sheet of strip from with or without heat sealable coating. In 1.2, the value stated SI units will be regarded as a standard. The value is given to parentheses information only. Note number one, this document is similar to IEC 60674 by Part 3 sheets 2 by 4 by 5 by 6 and 7. Next slide. Another standard is D5288-14 standard test method determine the track index electrical insulation material using various electrode materials excluding platinum. In 5.1, electrical equipment has the potential to fail result electrical tracking isolating material that expose various communicating environment is surface surface condition are a number of American standard testing management. A material and other tests have been designed to one quantify behavior of materials, especially the relative high voltage. This method is accelerated tests, which is really relatively the low test voltage provides a comparison of performance insulating materials under weight in constam- contaminated condition. The tracking index copper electrodes test is not related directly suitable operating voltage in service. In 5.2, when organic electrical installation materials are subject for conditional current between electrode on their surface, many minutes tree like carboxygenous path or track are developed near in electrodes. Those tracks are oriented randomly, but generally propagate between the electrodes under the influence of the applied potential difference. Eventually, the series track span electrode gap and failure currently shooting the electrodes. In 5.3, as other tracking test method for the example IEC 112 and testing method and D3638. This testing method is specifying test procedure that when the included promote the information that tracking set cannot be used for the either direct and relative service behavior of a material's specific design application. Tracking tests are used for the screening purpose only. In 5.4, the use for copper electrodes in this type of test was developed from the University of Cin- Cincinnati NEMA laboratories built by the members of Industrial Laminate Section. NEMA is now using the copper electrode waveguide gives a more than realistic value of the tracking index related. The rising system used to reinforce the subscribe the laminate in the general tracking test made with copper electrodes trend given lower values than platinum electrodes in the same types of tests. It is a factor copper is more widely used than platinum for electrical conductors. In 1.1, this is a test method developed the copper electrode to evaluate the low voltage up to 600 voltage tracking to resistant materials in the presence of the aqueous contaminant. In 1.1.1, it is applicable to consider the electrode material used for testing depending upon the application of insulating material. In 1.3, the values state electroman there's this method Standard using the measurement describe the responsibility material product as assembly start to step comprehend the factor required the fire hazard, the fire risk assessment of material products assembly under the condition of the 1.5 firing testing, inherently hazardous, adequate, safeguard personnel, the property shall be employed in conducting the test. Next, another standard, D5374-13 standard test method for forced convection laboratory ovens for evaluation electrical installation. In 1.1, those test methods cover procedure that evaluating the characteristic force conversion connection ventilated electrically heated oven operating over on or part of the temperature range from 20 Celsius above the ambient temperature up to 500 Celsius and used for terminal endurance evaluation electrical insulation materials. In 1.0, those test methods are based on IEC publication 216-4-1 and the technically identical to it. These application test methods are associated spec specification D5423 have replaced specification D2436. In 1.3, this standard does not corporate address all of those safety concerns. If not associated with use, it is a responsibility of user that the standard to establish appropriate safety and health practices and determine the applicability to regulatory elimination prior to use. Another standard is D5423 standard specification for force convention laboratory of evaluation electrical insulation. 1.1 This specification cover force convection ventilated electrically heated oven operating over the part of temperature range of 20 Celsius above ambient temperature 500 Celsius. Used for terminal endurance evaluation electrical insulation materials. In 1.2, the specification requirements for Type 1 ovens based on IELEC publication 216-4-1 and the technically identical to it. The requirements for Type 2 oven essentially identical to use requirements of specification D2436. This is specification and associated test method D5374 have replaced specification by D2436. And 1.3, while the oven concerned by this specification for intended primarily primarily for the terminal endurance evaluation, they can also use other whenever their characteristic can be then su- suitable for other application. In 1.4, the standard does not purport address safety concern. Standard concern associated probably standard and appropriate safety health and practices determine the applicability for regulatory elimination prior to use. Next page. In American Standard Testing Material D2054-24-14 standard test method for smoke ob- obs- obscuration of insulating material contain the electrical or optical fiber cables when burning in a vertical cable tray configuration. In 5.1, this test method provides a means of measure of variety for the fire test response characteristics associated with the smoke obscuration and resulting from burning. The electrical insulating materials contain the electrical or optical fiber cables. The specimen are allowed to burn freely under well when ventilated conditions for ignition by means of the propane gas burner. 5.2 Smoke obscuration quantities. The visibility of fireflies. In 5.3, this is a test method. It's also the optical fire testing response and application memorable method for the fire safety. Most important gas components smoking carbon oxide when fires. They are major indicators that toxicity of the atmosphere and complete, completeness of combustion and are often used for the part of the hazard assessment for calculation of the improvedness accuracy of heat release measurement. Other toxic gases which specific on certain materials are these crucial determining combustion completeness. In 5.5 test eliminators, in 5.5.1, the fire test response characteristics measured is the best method are representation the manners in which a specimen tested behave under certain specific conditions. Do not assume they are representative of a generic fire performance of the materials test, tested when they are made into the cables of the construction under consideration. In 5.5.2, in the particular, is unlike that this test method indicate representation of the fire behavior. Cables confine space without abundant circulation of air. In 5.5.3, this is an intermediate scale test, but the predictability of this result to large scale for the has not been determined. Some information exists but suggests that it has been validated against some large scale scenarios. The scope is this is the fire test response standard 1.2. This is the way to provide means measurement the smoke obs- obscuration resulting from burning electrical insulating materials contain the electrical or optical fiber cables where the cable specimen excluding accessories are the subject to specified flaming ignition source of burn really under the ven- ventilated condition. Okay guys, this is the ito na po ang muli namin report. Thank you for listening.